The Earth is very flat.
What's up, guys? It's Tuesday, July 27th. This is Brandon, host of Brandon's Show. How's everybody doing out there? Yes, it is Tuesday. No show yesterday due to the power outage. Sorry about that. Not much I could do about that. But happy to be here tonight. Out in the chat, we've got Arwen, Brian Leakey. What's up, man? Askin Raziv, White's Word, Ian Adams, PJ Cruikshank, The Plain Truth. I was just watching your video, man. James Richard, Sean Hawkins, Not Flat, and Page 42. What's up, Page? How's everybody doing tonight? Good? Good. Sound is good. Thank you, Bill G. Appreciate that. And as always, we've got an open panel tonight. We'll see where the discussion goes. You are more than welcome to join the open panel. Talk to us about the shape of the Earth and other related matters. And you never know what we'll end up talking about, actually. But come on and join the Discord. Link is in the description for the videos. And you can come in, listen if you want, or you can come in and present. Come in and challenge us on anything. Bring some new evidence, whatever you want to do. It is always open. So come on in. Anyway, let's go see what's going on in Discord.
A page out of Brandon's book, you know, and hold fast to where, you know, I feel like they have the burden of proof. And it seems to be a fair explanation for every point they make for a flat Earth. If not perfect, at least plausible.
I'd be happy to debate you, Brian, on and you know, with Mr. Sensible or McToon or anybody like that.
Brenda,
that would be good.
You think a hypothesis is a shoe? You think I'm really going to? No offense, but we'll say anything. Brian. I mean,
so
no, Brenda, but we'll stand behind anything. And
we could debate that. We could debate that, Brian.
All right.
What?
It is a debatable topic.
If you be honest, I'll ask you a few leading questions here in just a minute, if everybody's good with that. If you give me honest answers to 3 questions, that then I'll offer you a debate. I mean, you don't have to. I'm not trying to sound special or nothing, but if you can answer just 3 typical questions honestly, then I'll give you a debate. But I need a minute.
Yeah, Brenda, put your thinking cap on.
Oh, I've got it on.
Well, they're not going to be trick questions. They're just going to be, you know, a little fact with a bit of opinion.
Is this going to be where you think when I give you a scientific answer, you think I'm not telling the truth because you don't understand it?
Let me just go ahead. Okay, number 1. Okay, how do you think we would see indefinitely if the Earth was flat?
With the atmosphere, no.
Thank you. Okay, and so you would agree that the ground, our angular limit to resolve the ground, even if it was not perfectly flat, not a sheet of glass, but you know, fairly level, it would run out at some point.
The atmosphere would eventually reduce everything to like a haze in the distance.
Let me reword that.
Because the atmosphere would eventually, it has humidity, it's got dust, it's got other things. Eventually, you would not be able to see anything past a certain point. However, if the atmosphere, if there was no atmosphere, we could see indefinitely.
My point was, okay, so my point is, if we're looking at railroad tracks, let's say we're, instead of railroad tracks, picture them, but we're out on the water, and we put just a bunch of buoys. They're all under my feet. I'm looking at them. I'm standing, you know, just 6 foot tall, and I'm standing 6'6". No, I'm just kidding. But I'm standing 6 foot tall. I'm looking at these little 1 foot buoys. They're just going off in the distance on a level surface, level water. Do you think we would just be able to see indefinitely whatever buoy we wanted to key in on, or do you think there'd be a limit and they would jumble together?
The atmosphere, the haze, and the scattering of the atmosphere would eventually make it impossible to see past a certain point because the atmosphere is going to scatter the light. So if there was no atmosphere, yes, you could see indefinitely.
Okay, number 2, I'll give you credit for that. I don't 100% agree. I think there's also to be added angular limit, but I'll give you honesty points. Number 2, do you think there's a foolproof 24-hour sun Antarctic video that you could present right now?
Well, I don't know what you mean by foolproof. There are videos of a 24-hour sun in the Antarctica. Yes.
All right, number 3.
He's gone.
I think he just dropped out.
Oh no, he's there.
And number 3 was do you see some? Is it fair for us to point out what looks like suspicious activity on the ISS? Is it fair for us to point some of these things out?
Sure, you can ask those questions. Yes, you can ask questions.
And then a bonus question. Okay, good. That's honest. And then just a bonus question, man. I think yours is honest, but is this a great debate? Flat Earth Globers, is it a great debate?
What? I don't know what that
You
means.
think it's a great debate, a good, fair debate?
I don't know what that means.
The debate, whether the Earth is flat or a globe, do you think that is a good, fair debate to have?
No, I don't think it's fair because the people, many of the people mute and silence one side or the other. And so it's not conducted in a fair and honest way.
Well, yeah, I'll give you that. But what I meant was factually speaking. Would you agree that there are some decent evidences for me to declare that the Earth is potentially flat and level? Is there at least some fair evidence is worth looking into that you think that stand for a flat Earth?
Flat Earth has never presented a single shred of evidence. Do you have any?
And she blows it in the fourth quarter, people.
Could you present that evidence right now then?
Yeah, how about Marconi sending a transmission across the Atlantic? That ain't a fair debate, you think?
What?
That ain't worth fact checking?
Radio waves? Really?
How about whales, Brenda? What you have underwater? I mean, listen, I don't even know where to start, but let me finish. You asked. Hold on, you asked for one. You asked for a flat Earth proof. Well, so I don't even know where to start, but we're testing your honesty here. So now whales, underwater, we have what we call acoustic shadows with sonar. It maps out the ground, and other submarines are known to hide in acoustic shadows because the sonar signals are fairly reliable, and you can hide in these shadows. Well, whales are known to call over 4,000 miles, okay, all the way across the South Atlantic and South Pacific. Yeah. Wouldn't the other whales be well beyond, in acoustic shadow? I mean, my point is that's not a fair argument for you for me to declare that I think the Earth is a level plane.
So sound travels in water, and it bends and refracts. So I don't see how that relates to a flat Earth. Same with radio waves. Marconi sending radio waves. Radio waves bounce from the ionosphere back to the ground and then bounce back up again. They can travel long distances that way. That's how they work. This is not an evidence for a flat
I'm not
Earth.
saying there's not explanations. What I asked for is it a fair debate? Is there good evidence? You don't know what an acoustic shadow is? You got to bypass science. You have to deny science, deny acoustic shadows, and you have to deny what our eyes see. I mean, it's a fair debate. I'm trying to be fair to you, arguing for the globe that it's a good mathematical model. And to me, it's just not. It's not honest for people to say it's not a great debate. And there's great points to be made.
Do you have a model? Yep. Do you have a model?
Of course I have a model, okay? If you watched any of my videos, you'd know. Pick one. Yeah, pick one, okay? Okay, go to Bob. Yes, if you touch. Okay? I'm going to use the map that all the airlines use, and I'm just going to say the Gleasons, okay? It's scientifically accurate as is, okay? Not like the globe. Nobody travels with a globe, okay? So now I'm going to take this AE map or a Gleasons, and I'm going to project all the models, the atmospheric models, the magnetic flux models. I'm going to project the currents, the ocean currents. I'm going to project the topical, the seasons, the weather, the warmth, and they're going to look like jumbled up horse shit on a globe. All the flat Earth models look nice and fluent and concentric.
So your map is the Gleason's map, right?
You asked for models, okay? So I'm using an AE. I'm going to use the AE.
A map and a model essentially the same thing. They're similar.
Right. No. Why do the globe models look like jumbled up horse shit when we model weather, when we model tides, when we model heat, when we model jet streams, ocean currents? Why do they look like jumbled up horse
They're
shit?
not. They're not. So
Aren't they?
you're sticking with.
That's what I mean by dishonesty. I'm gonna shut up for you, but that's what I mean by dishonesty. You say they're not, but they are.
I don't think they're jumbled up. I don't think they are. They accurately reflect the Earth or whatever they're trying to depict. But you're sticking.
They
with
have
the
to be a model. They have to accurately represent.
Yeah,
but
they do.
visually feasible is what I'm asking. Okay, which one looks better? Does the flat Earth projections look better, or does the globe Earth projections look better?
I think that globe Earth. Go to Google Earth. That's our model. So I wanted to.
No, that's our model, Brenda. That's our model. You're not going to take Google Earth.
Sphere.
Google Earth
Dude,
shows no drop.
That's a sphere, dude. That's not a.
Okay, listen. I'll take Google Earth before. That's one of my sniglets. One of my sniglets is a Higgs boson, and that's the zone I just made up to where when Google Maps turns into a cartoon. That you can have it once it turns into a cartoon, but I'll take it down for the elevation profile, and I'll take it down for realistic.
Do you know what does the word elevation mean, Brian?
Elevation means higher or lower than sea level. Okay, just to put it simply for you.
And sea level conforms.
You know what elevation doesn't mean, Brenda? It doesn't mean distance from the center of the Earth. Okay,
yes, it
would you admit
does. It literally does.
It literally does not.
Yes,
okay.
It does.
No, it does not, because the WGS84 is mapped out on a spheroid. You're not being honest.
Yeah, that's fine. It's a spheroid. Whatever. It's still the same point. It's the distance from mean sea
from the
level.
center of the spheroid? Are you kidding me? The potato
distance
Earth?
from mean sea level. So that's what an elevation is. Right. So
satellites and GPS claim, and Neil deGrasse claim a potato shape. Y'all flat Earth deniers claim a perfect sphere.
Yes,
you can't have all of them, Brenda.
The equator is about 24 miles, greater than other great circles. So what?
In elevation, okay. According to the
24 miles.
WGS84, it's elevated at the equator.
It's 24 miles.
But anyway, you can't have all of them models, Brenda. You need to pick one.
Yeah. No, we pick them according to their use case. So how we're going to.
No, you pick one according to the argument, and it's not fair. Okay, they're going to call it a spheroid for elevation purposes.
That's how maps are used. That's how maps are used. So you're sticking with the Gleason. You're sticking with the Gleason. So you're sticking with the Gleason. So how far is it from Perth to Sydney, Australia?
I don't know. Figure it out.
The Gleason's map has it wrong.
Then move it over a little bit. Okay, if you think it's wrong,
move it over a little bit. It's not a little bit, dude. It's not a little.
I want to see proof that it's wrong. You're gonna have to show me proof that it's wrong. You can't just say
the distance.
How far is it? No, that's not right.
The people have measured the distance from Perth to how wide Australia is, and the Gleason's map gets it wrong.
Give me some proof for that.
What do you mean? How long have you been doing this? Fuck.
You think I'm going to go off your word? All I know is that
not my
flight
word.
is impossible to book. That flight, go try and book that flight right now, Brenda. Okay? See what happens.
It's not my word. It's a real objective distance from Perth.
How about this? It's a long way. It's a long way, okay? Map it out.
Yeah,
it's mapped out on the AE map, Brenda.
It's a long way.
Brenda.
It's a long way.
Brenda.
That's not a map.
You do know that the AE map is basically a projection of your globe, right? You do know that, right? You know that the circle's getting...
that's what the Gleason's
it doesn't matter.
Essentially. The Gleason's is essentially the AE map, and you're using the globe.
Why are you arguing it then, dumbass? Why are you arguing it? Because you're not honest.
It doesn't reflect the reality because it distorts.
The globe does not reflect reality. If you try to travel with a globe and go from England to America, you're going to think you're in India and you're going to wind up being in Central America. You're not going to get where you want to. That's why nobody uses globes to freaking travel. Okay, so let's get that straight right now.
They use
all your globes are all different.
completely accurate. So let's be honest with that. Do you have a perfect globe?
So people don't use globes because it's not convenient to carry around a globe. It's convenient to carry around a flat piece of paper. However, airlines use a projection that takes into account the circumference, the circularity of the Earth. You know, McToon has demonstrated that.
It's fudged. It's been killed 1,000 times over.
No.
It's your globe. I'm sorry. Deal with it.
Well, you can't tell me the distance from Perth to Sydney, Australia.
You can't give me an elevation profile and then say, no, that's not right. The Earth is curving.
Hell not, because you don't know what the word means.
You don't know how they figure in. You don't know how they do curvature corrections. You don't understand the math. You don't understand how they do it. But one thing I think you do understand from listening to us enough is that an instrument like an auto level, which is the most accurate for elevations, is a horizontal frame of reference. If it's lower than your crosshairs, that is a drop. You could call it a slope.
There's no drop. There's no drop. Dropity is something that flat earthers made up. It's dropity.
That's my case. To the dishonest person, this is as much debate as you'll get out of me. You're not an honest person.
You just don't understand what simple words mean. So if I take a paper mache globe, a sphere, and on that paper mache I add mountains and valleys, rivers, trenches, the Mount Everest, I model that, and I do it all the way around as a globe. Those are elevations. They are deviations from the globe, the flat globe, the
level means right, Brenda?
sea level. That's what elevation. That's what elevation means. It doesn't mean flat.
So level means curved, right? Level and flat means curved too, right? Does flat mean curved? Answer that honestly. Does
One
flat
second.
mean
Hey, Brian.
Level.
I don't want to interrupt you. I'm sorry to interrupt you guys, but Brian, your mic is making some weird noise. Can you do that thing? You guys can get back.
Do that thing. Do that thing that you.
Is that any better, Brandon? I don't know if it is or not.
Yeah,
a little bit. I think
better. Yeah, go ahead,
I think
man.
it is.
Continue.
Okay, yeah. If we could, then
level?
we could be honest and say that flat does not mean curve, Brenda. But according to you and Rufus, flat means curve.
Level means conforming to the curvature of the Earth, right? McToon has multiple citations confirming
What's
that.
the antonym? Give me an antonym of level, Brenda.
Irregular.
Okay, if you look it up, what you get is an antonym for level is curved. Okay, I know you don't like it, but it's reality.
Words
If it's
don't
not
have-
level, it's curved. You know what one of the top definitions are for level is not curved. I mean,
but this is words have usages. So as it is used in surveying, level means conforming to the surface to the surface of the
so
Earth.
our forefathers going across country and doing all these state surveys for them to, okay, so they were getting it wrong. They were supposed to be adding corrections, right?
No, they knew that they knew
levels. Hold on, let me finish. Okay, when they're adding, all they do is write down plus or minus. Okay, let's get that straight. When they're going off doing the levels before the electronics, they look through their auto levels or Duffy levels. They wrote down plus or minus. So if it's underneath, if it's above the crosshairs, however much it is, you write down plus 2.5 feet or however. If it's and that would mean so it's opposite. So plus would be a drop in elevation, okay, and then minus would be a rise in elevation, okay. So that's all they wrote down was pluses and minuses. So if you want to turn that into a ball, you're gonna have to add. You're gonna have to assume a radius, and you're gonna have to add datums, okay.
No, so
but
the
all
Earth
they
is
did is
measurably
give pluses and minuses to horizontal, Brenda. That was my point. I was almost done.
Those surveyors knew the Earth was a globe, and measured as a globe.
Brenda, does the auto level know the Earth is a globe? I'm not talking about them. I'm talking
no,
about what they
it doesn't.
recorded.
The auto
You don't know nothing about auto levels, Brenda, so I don't even know why I'm
So
bringing this up.
it's
You
simply
act like you do. You act like you're an expert. This is what you do. You act like you're an
it's
expert in every
simply-
topic.
No, the auto level
Oh,
is
the
just
auto level.
the auto level is just an instrument, right? It records what is perpendicular to the force of gravity, to Plumb.
And it shows us what? A horizontal frame of reference.
And horizontal is 90
All it
degrees.
does, Brenda.
Horizontal is 90 degrees to Plumb, right?
All it does, let me school you, okay? All it does is it levels out perfectly, and
I just
it has
told
a
you what it
scope
does.
with
You
crosshairs.
don't have to explain
Okay?
it. I
You
just
don't own
told you.
one. You've never used one. I've been using one my whole entire life, Brenda.
I
okay?
don't care. I just told you what it does. It shows you what is
Honest
perpendicular
sometimes.
to Plumb, right?
Okay, you can read directions, okay? How do you set up an auto level? Tell me.
Does it read perpendicular to Plumb? Just confirm
Tell me
that
how.
for
Tell
me.
me the simple. How do you set up an auto level, Brendan?
You're gish galloping and trying to move the goalposts.
No. I'm seeing how honest you are. How do you set up an auto level,
I
please?
just want you to answer the question. Does auto level establish horizontal as perpendicular to Plumb?
I'm gonna answer your question, and I demand you answer mine. Okay, or else this is over. An auto level establishes a horizontal frame of reference. Now, how do you set up an auto level?
I don't know.
Thank you for some honesty. For God's sake,
It's irrelevant. It's irrelevant. The point is a conceptual point. The auto level determines what is horizontal as perpendicular to the local plumb line, right? And the problem for you is...
Are you asking me a question? Do you want to know how to set up an auto level, or do you want to know more about an auto level, or what?
I was not asking you a question. I was going to say something. I was going to say the problem for you is that different horizontals at different points, they're separated by a distance, those angles will not add up to 180 degrees. So the plumb lines will not be parallel.
That was pretty fun, though, man. Ladies and gentlemen.
Do you understand that plumb lines established by different stations will not...
Listen.
Do you understand, Brian, do you understand that the verticals established by different stations, right, and their attending horizontals, the local horizontals, those angles will be greater than 180 degrees?
You know they won't. They can't possibly be, or else they wouldn't be line of sight, fool. No. If I can see one point, and then that other point can see the other, they can't possibly be more than 180 degrees. Even if the Earth was a sphere, you're going by math, and you're assuming the Earth is a ball, and that's the only way to get more than 180 degrees out of that. That's
doesn't
not
follow.
honest.
That doesn't follow.
You cannot have a triangle with more than 180 degrees. It wouldn't be a triangle.
Yes, you can.
No, you cannot.
It's called
you can have a triangular-like object. You could have a triangular-like object on a sphere, but it would have to be further than your. Listen, Brenda. It would have to be further than your point of view. It would have to be out of your point of view, or it couldn't be more than 180 degrees. You understand that? Wait. Do you understand that? Answer me. Let me know if you at least understand what I'm asking.
Well, why don't you repeat it? Because you were over talking me a little.
No, it wasn't. I'll let you finish. But look, you're talking about a triangle. This is my response to your more than 180 degrees. If they are in line of sight, they cannot be more than 180 degrees. If you want to go beyond line of sight, then you can make that argument. But within line of sight, if I can see 3 points, then that is 180 degrees.
Yeah, that's false. That's false.
Oh my God.
It's provably geometrically false.
No, it's not.
If I can see 2 points, what do them 3 points make up, Brenda? If I have a line of sight to two other points, and all points have line of sight to the other two other, it can't be more than 180. It's the definition of 180 degrees, jackass. Sorry.
Right. So if you can see another point, you have a straight line between the two, right? That doesn't follow that the horizontal established perpendicular at one point will not add up to the 90 degrees of the horizontal at the other. The two horizontals will not be will not add up to 180 degrees. They'll be more than, and the plumb lines will not be parallel.
So
Cut out.
is that what you're telling me? That's what it sounds like.
I didn't hear because you cut out.
No, I said, so my line of sight is curving. My line of sight from point to point
No,
is curving.
no,
That's what you're implying.
no,
That's what you're implying, Brenda.
no, I'm not.
It is though, Brenda.
No, it's not.
If you think I can get an instrument or a telescope or anything and I can see from point to point to point, then what you're saying is if it's over 180 degrees, then my line of sight has to be bending. That is what you're implying. You just don't know it.
I'm telling you that the verticals established at, say, station A and the vertical established at station B will not be parallel. And therefore, the horizontal at station A plus the horizontal for station B will not add up to, the angles will not add up to 180 degrees. They'll be more than.
That's the whole debate, Brenda. You're not just going to make the claim and claim victory. The whole debate is we claim, and it's easily proven let me finish, man. Let me respond. I just listened to you. You keep interrupting me. Okay, now, the whole debate is whether these plumb lines are parallel. To me, it's easily proven that they are parallel and they are perpendicular to horizontal. You say they're not, but you can't prove it. But don't just make a claim and act like you won just by claiming that they're not perpendicular to horizontal.
Right. I'm not making a claim. I'm referring to data that has been.
You're referring to data assuming a sphere, Brenda. Now, we have had many people admit that, honest people, okay? You just aren't one of them. If I assume a sphere, then I have to assume that them plumb lines are deviating, okay? But
I am
without assuming, brother.
I'm not making assumptions, Brian.
You can't do that measurement without an assumption, Brenda. It's not a measurement. It's a calculation.
It has been done.
You can't, Brenda, you can't see. Ask George Numchucks, okay? The margin of error is well within. You got to go 69 miles per 1 degree, okay? Only if you want to, we could get on. Man, I don't even know where to start. But this is a whole debate. You can't just.
Can I take a crack at explaining your?
Yeah, I wish you.
I don't think she
would, brother. I wish you would. I'm getting exhausted.
All right. I'm sharing my screen now, Brenda. This is the point that Brian was trying to make. Let's say we have 3 people, and they all each go to 3 separate points. And from point guy A to guy B, we make a line. From B to C, we make a line, and then from C back to A, we make a line. All 3 of these people see each other, and we draw a straight line between all 3 people. 100% of the time, that has to result in a triangle with interior angles of 180 degrees. That cannot possibly have more than 180 degrees. That is basic geometry.
Yeah,
that's the point.
Yeah,
Brian was making.
This is not the case. This is not what we're talking about here, though.
That was his point, and that's what you argued.
No,
so
but his point has nothing to do.
If there's line of sight between 3 points, from point to point, point to point, and point to point, it is always going to result in 180 degrees. So at that point,
that's not true, unless you live on a 2D plane. That is only true if you live on a 2D plane.
No, it is always true, no matter what.
No, if there is a 3rd dimension to be in, it is not always true.
So explain to me how that could possibly happen.
So if you are on a sphere, and I'm not saying that we are, but if you pick 3 points on a sphere, the triangle that you would make there would not have 180 degrees. It would have more than 180 degrees.
If this guy is above the ground, he's looking at this guy. We draw a line through space between these two. This guy's above the ground. He sees this guy. We draw a line between those two. This guy and this guy can see each other. We draw a straight line between those two. How in the possible fuck could that be more than 180 degrees? Where are you getting your curve from?
Mathematically. That's how they're getting it. They're getting it mathematically because It has to be more than 180 degrees, no matter how long it is. But in reality, and logically, it can't be more than 180 degrees because that's the definition of the degree itself. That's the definition of the damn angle and the triangle itself. Thank you.
So, Gummy Bear, can you explain to me how, if these are all three of these people have line of sight to each other, and we draw a line through space between each one of them and connect all three of them with a triangle, how could that possibly be more than 180 degrees?
If you look at the picture I posted in chat, it's the best way to explain it. Even though there's line of sight between all those 3 points, does not mean that the so-called triangle you make up of them is exactly 180 degrees.
No, it has to be. It has to be. What you've got here is something different. You don't have straight lines connecting B, A, and C.
Even if you were to make the lines
connecting them.
Even if you were to make the lines straight, you would have the same problem with.
This backs up my point,
these
y'all.
lines straight. Hold on. If I make these lines straight, it will be a fucking triangle with 180 degrees.
Gummy Bear, let me make one more point. This is what I mean by mapping shit. By you can't use the map. You can't use GPS to prove GPS, or you can't use a globe to prove a globe. It depends on how you map the ground underneath that perfect triangle. Okay, it's obviously a perfect triangle. Once you see that, you'll understand that it all depends on how you map the ground underneath. I can make different datums to my city. Okay, if I keep you away from the edges, you couldn't prove that it wasn't spherical, or maybe a little bit bigger than the city. But the proof is in the pudding. So, but it doesn't prove either way. That's my point. A map can't prove a map. A globe can't prove a globe.
Well,
I mean, line of sight is going to be 180 degrees, because for you to say it's not, you're saying we see in a curved path. Now, the only way you can then get your three-dimensional is if you presume you're standing on a globe, which is what you said you weren't doing earlier. Line of sight is straight, unless you see around corners. That's the only way you can justify it.
Just to circle back, Gummy Bear, to the point you made that if I connected these with straight lines, it wouldn't be 180 degrees. I took the triangle tool, which always results in a triangle that has 180 degrees, and I mapped out A, B, and C, which connected them each with straight lines.
But you mapped them
with 180 degrees.
You mapped them out on a 2D triangle. I'm not talking about mapping it out with a 2D triangle. I'm talking about mapping out point to point with lines in the third dimension.
No. You're talking about.
It wouldn't look.
You're not
like
talking
this,
about
no.
line of sight between points, then.
No, that is what I am talking about.
No, you can't be.
What do you mean? I can't be talking about. That is what I am talking about.
You cannot be talking about line of sight where all 3 points have line of sight to each other and be talking about anything besides a triangle.
This is what goes on in their mind. In their mind, it's proof. But when we try and explain it to them to show them that the globe doesn't prove a globe, they don't understand it. They just not only do they not agree with it, they don't understand it. We don't agree with all their arguments, but we understand them.
Let me explain it a little better.
The theory proves this. But what can prove this is if we make a measuring tool that assumes it's a sphere, and then we get accurate measurements, then you have no other explanation than it is a sphere.
The measurements you're speaking of are outside of margin of error. George, I'm trying to tell you.
That is the explanation you always have. You never come up with any other explanation besides it's a sphere. It seems to be your one and only hypothesis. But back to my point, if I connect A and B, no matter where I put C, if I connect A to C and B to C, no matter where I move this, let's say it's 3D space, I'll draw it out this way, I'll push it back that way, I'll bring it over here, I'll bring it over there. If they have line of sight, there is no way you can connect 3 straight lines like this without it resulting in a triangle.
I have a picture showing you just that.
No, you don't.
Yeah, I do. I do.
No, you don't.
Yeah, it shows two stations establishing plumb and horizontal, the local horizontal, and the line of sight is not the same as the horizontal.
What the hell are you talking about? So where's our A, B, and C on this diagram? Let's compare it to this triangle here that we're talking about. Where's the A and B and C on this diagram that you sent?
If they're trying to prove a globe, they do not need to talk about geometry or triangles. It's a killer. It just maps out that they have a model, and it's hard for them to accept because it's just a model. People, it could be true, it could be not true, but it's only a model. Any way you look at
the question though, Brenda, where is the A, B, and C that is comparable to this diagram?
I've loaded up the image and I'm sharing my screen, right? And here's the image. It shows two stations, two occupy stations, station A and B. They both establish plumb and local horizontal at line A, horizontal at line B with 90 degrees. The line of sight is not coincident with the horizontals at either A or B, and the angles between plumb and line of sight add up to be greater than 180 degrees.
Brenda, where are A, B, and C in this diagram that is comparable to the triangle that we've been talking about? Point to them with your pointer.
This is what I am talking about. I am saying that when you establish a plumb and a horizontal at station A and at station B, the angle from line of sight to plumb at both stations adds up to be greater than 180 degrees.
You are talking about something, a different situation. You have 2 points here. You have A and B that have line of sight. That's all you have. You add point C with line of sight, and you're going to get a fucking triangle between the three of them because you're not comparing apples to oranges right now.
No, this is what I have been talking about the whole time. This is what I've been talking about the whole time, Brian, and you have misunderstood the subject of what I am speaking about, which is that when you establish plumb at station A and at station B, you measure the angle from plumb to line of sight, not horizontal, line of sight. The angles add up to be greater than 180 degrees.
Are we talking about angular excess or not? What is it called? Angular excess?
Yeah, this is
called triangular excess.
Yes.
Triangular excess. Are we talking about triangular excess, or are we talking about something different?
It's spherical excess. It's spherical excess.
So what you've got right here is you've got two lines that you claim are plumb. You've only got point A and point B. So just to be clear, we are not talking about the same thing because triangular excess would be 3 points mapped to the surface of the Earth that would result in this A, B, C, the blue one on my screen. Not the red one, the blue one. That's your claim.
So this is what I've been talking about the whole time. The fact that the Earth is curved and gravity establishes what is vertical, and those verticals are radial from the center of the Earth. They are not parallel.
So what you're saying is
the
great circle routes are not straight lines then. So what you're saying is the great circle routes are not straight lines on your globe.
So in spherical geometry, a great circle line is a straight line.
Okay, and if you have 3 of them, line of sight,
don't let her get away with that.
Degrees.
Are you saying a straight line is a curved line, Brenda?
In spherical geometry, a straight line is axiomatically defined,
but not in reality. But not in reality. Line of sight is straight, Brenda.
Yep.
Brenda, in reality, a line of sight is a straight line. I'm sorry.
Sphere is only in your head. Another question, Brenda. Can you get an angle without
exist in reality?
Can you get an angle without 2 straight lines, Brenda?
Sure.
You get what do you mean? It depends on a sphere. Yes.
Then ask you on your magical, mythical sphere. Answer the simple question.
Spheres are not mystical.
Can you get an angle
Globes are not
without?
mystical.
Are you done?
Yes, you can get an angle to curved surfaces. Yes.
You can get an angle without two straight lines.
Yes, you can.
Yes.
Nancy.
You heard it here, everybody.
Shout
You
out to
are
the skateboard
delusional.
paradox. Woo!
So you can have a triangle without three straight lines, Brenda. Is that what you're saying, Brenda?
If they're in spherical geometry, a great circle.
I didn't ask you
is
about spherical geometry. I asked you a simple
They're
question.
defined as straight. You're not asking a simple question. You're presupposing Euclidean geometry, and there are different types of geometry. There's Euclidean, non-Euclidean, and spherical geometry.
Okay, Brenda, when you went to school in grade school and your teacher asked you to draw a triangle, how did you draw it and what did you use?
When I took geometry in the, 8th grade, we were taught Euclidean geometry. So
Real life, in other words, real life geometry.
No, so the way math works is from axioms. You would learn this if you'd taken geometry. The axioms establish the system, the geometric system that you're operating in. Spherical geometry has different axioms. Non-spherical pseudo-spherical geometry has different axioms. We are allowed.
They are applied axiom. They're applied data. They're not measured.
Yeah, we are allowed to create the axioms we wish to create the geometric systems that we wish because they suit our purpose.
So when you gave your teacher a triangle without three straight lines, what did she tell you, Brenda?
Well, he was a he, and it was Euclidean geometry, right? So we did proofs going from Euclid's axioms. We didn't study trigonometry and spherical geometry because that would be college level.
Yeah,
So
but
you drew a triangle with three
geometry
straight lines, correct, Brenda?
Within Euclidean geometry.
So you drew a triangle with three straight lines, correct, Brenda?
Straight as defined by Euclid.
Straight, as in not curving.
No,
as the opposite of curving.
No, that's not the. Do you know what the Euclidean axioms are? What is the definition?
Straight is a great circle.
What is the definition? What is the definition of a line in Euclidean geometry? It's defined axiomatically. What is the definition?
That's not what I'm asking you, Brenda.
Yes.
Did you
don't know
draw
what
a
it is.
triangle with three
Everybody here
straight
knows what it
lines?
is, Brenda. Sorry.
Yes
A
or
straight
no,
line.
Brenda?
A straight line is defined as the shortest distance between 2 points. On a sphere, the shortest distance between 2 points is a great circle.
Not talking about your mythical
I think that's
sphere.
backwards.
No, it's not. We start
The
with
shortest
the axioms.
distance between 2 points is a straight line, not a straight line is the shortest distance between 2 points. The shortest distance between 2 points happens to be a straight line.
Absolutely.
No.
Without any
This
question,
is
Brenda.
how things are defined.
No, you define things differently in your sphere fantasy. We live in reality. In order to make a triangle, Brenda, you need three. Not two, not one, three straight lines.
Maybe not.
All right, well, let's look up the definition from Euclid. I think this is out of his work. From Elements, a straight line is a line which lies evenly with the points on itself.
Yeah, but that's not the modern definition.
Brenda, can I make a globe, okay, if I don't know the radius with just an auto level?
What?
Repeat that question, Brian. Did he drop off?
The question was, can you have a sphere without, can you make your sphere without a radius? Can you use an auto level to
What?
You're not making any sense.
Globe. without a radius? The answer is no.
Oh
gotta
my
have the
goodness, your
radius
audio
to make the datum.
your audio is so much better. Keep doing that.
Brenda, do you know what the law of non-contradiction is? While Brandon is
Yes, I
looking
do.
up.
Yes, I do. Do you know
Can you
what
please
general
tell us?
arithmetic is? The law of non-contradiction?
Yes, please.
It says that you can't have something be its opposite at the same time and in the same respect.
Beautiful. Can you please define a straight line for me?
The shortest distance between any 2 points.
Would that be straight? That would be straight, right?
I just defined it for you.
Perfect. Can a straight line be a curved line?
On a curved surface, if it's the shortest distance, then it's a
I
line.
hope everybody's listening to this double speak.
It's not double speak. Show me the contradiction. Show me the contradiction.
Can I show you the contradiction between a straight line and a curved line? Are you on medication?
Listening live on YouTube, and Brenda, you're contradicting yourself if you say that straight is also curved.
No, I'm not.
Absolutely, Rob.
No, I'm not.
Yeah, so now flat is curved, flat is curved, and straight is also curved. So we don't even get a word. They won't even
Yeah,
get
they
a
live in a dual world. Left lane, you guys.
For a perfectly straight line. What word do we use? If you're gonna not let us use straight, you're gonna not let us use level. You're not gonna let us use flat. What the F can you use?
Fine. They don't control the words that you use. The definitions are good enough.
Yeah, but we're doing a good job exposing their dumb asses, bro.
Hey, one other
So
thing
Brenda,
I noticed
let's
during that
get some
conversation
clarity.
between Brian and Brenda
Sorry.
was that Brenda defined elevation as the distance from the center of the Earth, which is nonsense in the first place. But isn't it
Well, that's
defined
presupposing, right, Brandon?
as obviously, but that's not even the definition within their model, as I understand it, since they've got a oblate spheroid. They measure from the theoretical, what is it called? Sea level.
Yeah,
That's the
sea
zero.
level, to be exact.
There's nothing to do with the center of the Earth.
Would like to know if they have an
Absolutely
answer
nothing,
for his
Brandon.
question, though. What is the word for a line that has a single line that has no curves or variations in it whatsoever? What is the word that they use if it's not straight?
Euclidean straight line, maybe?
What?
I've never
Maybe you
heard
want to
of
use the word
anybody
Euclidean
parse the
straight
word
line
straight
to
line.
be very sure.
I don't think half of these globe defenders have even read any of Euclid's work.
We're just
Are you
talking
telling me,
about
Gummy
a
Bear, that
single
there's more than
line
one
with no
definition for a straight
variations in it.
line?
That's it. What is that line called if it's not called straight?
On a sphere?
So a line is determined by 2 points, right? You know that much. We have that much in common?
You mean the shortest distance between 2 points?
You can't have any, if you're talking about 2 points, okay, the distance between them is always going to be straight, always, period. Okay, now you can put it
Always
on
and
a line.
forever.
You broke up. I didn't hear part of that.
Okay, the distance between two lines, the shortest distance between two lines will always, in reality, be a straight line point to point. Now you can put it in a
No,
model.
they won't be.
The answer would have been, in our model or on a globe model.
Well, even on a sphere, it still is the shortest. It's just you don't generally go through the Earth to get somewhere. But it would
Right,
still be the
exactly.
shortest.
Exactly.
So a straight line is still the shortest, and it's not curved at all.
Yeah.
It just goes through the Earth, right? According to your model.
No, that's wrong.
You just
So you're saying-
contradicted yourself,
So
Brenda.
if two people were to race from basically one point on the Earth to the exact opposite side of the Earth, and they went the exact same speed, and one went through the Earth and the other went around the Earth, you're saying the one who goes around will get there first?
Oh, the rule is you're not allowed to go through the Earth.
Okay, so like I said, the straight line that is the shortest distance is technically through the Earth.
No, not in
around
spherical.
it.
That's wrong. Not in spherical
No, it's not.
geometry. You're restricted in spherical geometry. You're restricted.
Wait, why are you?
to
Wait,
this-
wait, Brenda.
this-
Wait,
can
Brenda.
I finish a sentence? Can I
No,
finish a
no, you
sentence?
cannot.
No,
then
because
I want to finish a sentence because I would like to
We're not talking
complete my
about
thought.
Euclidean
I
geometry.
would like
If you
to complete my
convert
thought.
to
I would like to complete my thought. You are interrupting me. You're interrupting me.
If you
You're
convert
interrupting
to
me.
spherical geometry,
I would like to
and we're
complete my
not
thought.
talking in the
I know
same
that
language.
you
No.
need to
No.
overtalk me.
Spherical
in order to
geometry
Hold on,
is
let's
not
not
so.
get
I would like to
Spherical
started.
complete my
geometry
thought.
is not what we're
I
talking
would like
about,
to
Brenda.
complete my thought. Let me talk.
Dumbass
You need to
Let her
observe the elementary rules of conversation.
Spherical geometry is not what we're talking about.
That's
We're
is
not
what we're talking about. That's what I'm
spherical
talking.
geometry.
That
No, you're
is
not.
what
We're
we're
talking about
about.
Euclidean geometry.
No, we're not.
Euclidean.
No, we're not. We're talking
And
about
Euclidean for the
spherical
last
geometry.
10 minutes, and you just brought up spherical. Don't fuck around.
So on a sphere, right? The route from point A to point B would the shortest distance would be a great circle route, and that is defined axiomatically as a straight line.
What we were talking about is connecting 3 points that have line of sight with each other. That was the original topic that we were talking about, correct?
Yes, and I showed you how
No, you didn't.
the angles will add up to be greater than 180
No,
degrees
you did
between
not show me
station
that
A and
because
station
it's
B.
impossible to connect 3 points that all have line of sight with each other and come up with anything other than a triangle with 180 degrees. What you need is what Brian's original point was, is for
objectively
there
wrong.
not to be line of sight or for you to add an assumption afterwards. It's very simple. That was the only point he was making.
So what I'm giving you is empirical evidence, and what you are giving me is
You've given me a
rhetoric.
diagram. That's not empirical evidence, Brenda.
It's based on real world empirical measurements.
You don't even know the definition of empirical evidence.
Fuck, Brenda.
She doesn't even know
Yes,
what
I do.
empirical is.
What does empirical mean?
Tell us.
Go ahead, inform me. What does empirical mean?
You brought it up.
Repeatable
Why are
and
you asking me to
demonstratable.
explain it? Show us your empirical evidence of what you said. You made a statement. Back it up.
No, she'll just
I
draw
gave
you
it
another
to
fucking
you.
picture.
I gave you the evidence. Well, the picture
you're
is
just
based
blabbing.
on data.
You
No,
gave
I'm
us
not. It's
a
based
model.
on
You
real
gave us a
world.
model. Don't give us a model. No, it's not real
No,
world.
I didn't. I
Give us a
gave you
diagram,
a
Brenda.
diagram that is
Give us a
based,
diagram. That's all
based
you gave
off
us.
of
That's
real
not
world-
evidence of anything. I can
no.
draw a diagram of a fucking
it's
pig flying.
it's based off of observations, data.
Right.
That's
WS
empirical.
posted it. WS posted
That's
the
what
empirical.
You do realize that in the early 900s, the datums were 100 square miles, right?
Mickey Mouse is
datum.
based off of an
Not
animal that
datum.
actually exists too. Whoop-de-doo.
Do you know? Well, the people that challenged me to define empirical. Do you know what empirical means? What does it mean to you? Maybe we're using different definitions.
Demonstrable and repeatable. Okay, now don't
Yes.
quit obfuscating.
Yes,
You do know
so-
that in the early 1900s, okay, that the datums, okay, were 100 square miles. Okay, so it's like a disco ball. It's just got a little bit, the squares, the planes have gotten smaller as times went by.
So-
You do realize that it's just assumptions. It's not provable. You do realize that I can take an area and map it into a sphere using longitudes, okay, and keeping you away from the edge. You do realize that, right?
So the diagram I showed you is based on data that is empirical and is repeatable and verifiable.
So fingers and ears. So you don't realize then
I
that you
just-
can map something with longitude. You can map a flat surface with longitude and latitude into a sphere. Do you understand that? Because everybody else here does.
No, you can't, because there will be a discontinuity between a flat surface and
Where?
a curved surface.
Where would the discontinuity start becoming more and more apparent?
You cannot take a measurements from, say, the rind of say an orange and make it flat without distortions.
Okay, another honesty check. Where would the the discrepancies become more and more apparent. Where?
You
Away from
can
what?
choose. You can choose where the distortions are more apparent. Typically, you
No,
want to
from
do
the
it at
center.
the
It depends. Whatever spot you put in the center, away from that is going to be that's the honest answer. Is away from the center. So yeah, you can change the center, but away from the center is where the distortions are going to become more and more apparent toward the edges.
That's one.
Okay?
That's
Would you
one
agree with that?
limitation.
Wait. Would you agree with that, BioDual?
Right. Yeah, but that's half of it though, because you can place it.
But do you understand that I could take a big area, like a big city or state? It might not be accurate, okay, but I could map it into a sphere.
You could place
datums.
it. You could place it on any shape you want. What's going to happen is that you're going to have distortions most likely when you.
Well, she doesn't understand that, but
Yes,
you would
Brenda
agree that
just
the
said that.
bigger.
I just
would you
said
agree
that.
the bigger?
Right,
Hold on.
Brenda
Would you
just
agree?
said that.
Wait. Would you agree? Yes, the harder it would be to prove. Would you agree with that?
You cut out. Can you repeat it?
Would you agree the bigger the radius of that sphere you're projecting onto, the bigger the radius, the harder it would be to prove or disprove?
No, it's just called. That's called scale.
Then you're not honest. You're not honest.
Hold on, Brian.
Because if I did it
Brian,
with a
I can
city,
explain it, right? Can I
No,
explain
hold
it
on.
instead
What
of
you're
you
saying,
interrupting me?
I'm gonna let you
call me
talk.
dishonest, I would like to explain, right?
No.
That'd be the
Okay. Well, let me
logical
tell
thing
you
to
why
do.
I called you dishonest. Then, so
Would
we're
it
on the
be
same
honest for you
terms.
to not allow me to clarify?
You
Would
just
it be
want to
honest
babble.
with
Hold
you?
on, listen. Don't babble. Listen to me.
You're
So in
the
other
one
words,
babbling.
if
I
I
answered your question
map my
honestly,
city
I'd
as a
like to
sphere,
clarify.
would it be easier for you to disprove my city as a sphere or
Brian,
my
I'm
state
going
as a
to ignore
sphere?
everything that you're saying because I need to address what you claim me being
Ignore it,
dishonest
bud.
was.
Would it be easier for you to disprove
Again, I'm gonna
my
ignore you
city
right
as
now.
a sphere or my state as a sphere,
Right, so
pal?
I'm ignoring you. So I'm going to address what you called me dishonest for. When you're talking about a different radius,
Dishonest
all
is you
you're
won't
doing-
answer that fucking question, asshole.
What's dishonest is interrupting me constantly. So what I'm going to say is from what you call me dishonest for, that's just called scaling. Scaling is not going to do shit for the distortion. The distortion occurs because you're changing shapes, such as a 2D plane to a 3D sphere.
Okay, I'm sorry. I thought you understood.
So the radius,
I apologize. I thought
the
you
radius,
had an understanding, so I do apologize.
The radius value of that sphere won't cause or diminish distortion. The distortion.
Let me put this in elementary school terms so you understand, okay?
God. I mean, how far do you want to spiral, Brian? How far?
Would it be easier, listen, pal, would it be easier for you to disprove my city is a sphere or my state is a sphere?
I don't know, Brian. You tell me.
Yeah, I think you do know. Would it be easier
Right.
for me to
The
prove
city-
my
the city and the
would it be
state don't
easier for you
change
to
the
disprove my country as a sphere or my city as a sphere? How far do we gotta go, bro? I'm already in elementary.
Totally
so you want me to go to preschool?
That's totally separate from what you brought up with the radius, because when you're talking about.
So you don't like honesty, do you, pal?
I mean,
because
at
the
some
honest
point,
answer would be.
I should be allowed to finish.
Let
right?
me-
There is a universe in which
Go
I
ahead.
can finish, right?
Yeah, go ahead.
Is this that universe?
Would it be easier for you to map a universe
so-
as a sphere
so this
and
is not
disprove
the
it,
universe.
or a city?
So this is
You're
not
not
the
fucking
universe,
honest,
then.
dude.
Okay. So this is not the universe in which I'm allowed to finish, but
All
you
right, just
are.
go,
Gave
Bob.
you an
You're gonna babble some dishonest crap.
Then let me.
Brian, let him finish.
Let me get to the
Biodual,
end
go
of it.
ahead. Enough meta shit. Just go.
Let me be dishonest, but let me get to the end of the dishonesty. So what you're talking about between the city and the state, I understand what you're saying, and that's essentially what we would provide to you on a globe Earth, where we change latitudes, but we're at a particular zoom. I get what you're saying, but that has nothing to do with the radius of that sphere. The radius of that sphere, whether you're looking at the city or the state, doesn't change despite this distortion being more apparent changing. Only because you're changing the latitude, but changing the sphere doesn't add or remove distortion. It's just the shape.
Could I give my country? Could I give it a radius and assign datums and map it on a ball?
You could, yeah.
Thank you. First,
Guys,
honest fucking
could I
thing
get
said.
one
I rest my
final
case.
question in, and then I won't say anything else to Brenda, please. Brenda, can you please show us the data that you have for what you were saying before?
Yeah, it's published.
Yeah,
by the
I
main
want that
survey.
data too.
I think
I'll
something
give
was
it to you.
posted.
The guy from Maine?
Another diagram. I'm sharing it on my screen right now. Of course, we'll have to have some discussion about the methodology and how this data was derived.
Yeah,
Okay,
she said
okay.
empirical
The main-
data, Brandon.
Okay. The main surveyor, right?
Okay,
Okay, these are just numbers.
Excuse me. If you're asking me for stuff, you need to allow me to talk. So I posted a link to the video in question, and he has links to his website, and the data is posted both in the video And on his website,
he's a geodetic surveyor. He surveys borders, boundaries. Okay, geodetic surveying is not for elevations, people. Get that to y'all skulls.
Brian,
Geodetic surveying, it is not survey for elevations. For God's sake, man.
Brian, why are plumb lines not parallel?
What?
If they're
Straw
not,
man. Nice straw
so
man.
then your brain is warped like them plumb lines. Because in reality, plumb lines are always parallel. They can't not be.
They're observably, measurably not parallel, and I gave you the empirical observations that confirm that.
No, you didn't.
Yeah, you said that the triangle's more than 180 degrees when we know that's not. It's possible in your model. It's just not possible in reality, Brenda. I know you're having a hard time accepting this, dear. But it's reality. I'm very, very sorry to give you some reality. It's getting me frustrated, but it's okay for your It's just not okay for reality.
So you're just begging the question.
No, you are exactly begging the question. Oh my God, people project much.
You are begging the question.
Is everybody hearing this?
She's trying to piss you off, Brian. She's trying to.
No, I'm not. I am not.
Yeah, let me calm down. Let me calm down.
Yeah. When Brian called me dishonest, that wasn't Brian.
Dishonest answers,
But when Brenda said something, yeah, that's trolling, sure.
So
the honest answer would have been, yeah, it'd be harder for me to disprove a sphere if it was as big as a state than it is a city. That would be the honest answer, and everybody knows that.
The whole time. It just not appreciated when you interrupt people.
Allow me to state the problem that you face is that empirical observations demonstrate that plumb lines are not parallel. You need to account for that. You need
Brenda, on a globe, listen, on a globe, that would be true. In reality, let me repeat, in fucking reality, that is false. You fucking retard. Let me calm down. Take it over, Brandon.
Empirical observations are done in reality.
Assuming a globe!
No, it's not.
Hold on, Brian.
They're not
Brenda,
based on assumptions.
So you
Brian's
made
not
a
a period
claim
today, is
that
he?
we have these diverging.
Yes.
Okay.
That's the claim. It's based on empirical, observable, measurable observations.
Okay, I haven't seen the empirical evidence for that. I've seen arguments
I've
made,
shown
but
it to
I
you
haven't
over
seen.
and over and over.
No, you
Assuming a globe! Oh my God, man! I'm
shown
out.
us
I'm
that.
out. I'm out.
You've
I doubt
talked
you're out.
yourself
You'll be
into
back.
that's what you're seeing, but I don't believe that you can make that claim based on what I've seen. Sorry.
These are observations made in reality, empirical, measurable data that proves that plumb lines are not parallel.
The main surveyor
They're
would
not,
not
Brian.
argue.
Keep repeating it over and over again. I understand that you believe that there's evidence for that. There is.
It's not a belief. It's not a belief. It's a measurement.
The main surveyor would not argue that it's
You have
assuming the globe.
interpreted some kind of data or something you've seen as proving that this occurs. But
It's
you
not an
haven't provided us
interpretation.
anything other than you saying over and over again that that's the case.
It's not
It's
an
dishonesty,
interpretation.
Brandon.
Not an
It's
interpretation.
dishonesty.
It's a
has
measurement.
demonstrated this.
Anybody honest
And now
will say,
Rumpus
yeah,
is going to repeat as
assuming the
well
globe,
that this has
and that's
been
true.
proven
Yeah,
as
the
well.
main surveyor has demonstrated this. Why are you
I've seen the
rejecting
main
that evidence,
surveyor's
Brandon?
work.
It's assuming a globe.
Why?
ridiculous.
No, he's not shooting. He's making an empirical
Hey,
measurement
what
that shows
was
the
the
parallel
Game's
line,
over.
Hey,
vertical
Rumpus,
line is
Rumpus,
not parallel.
Rumpus. How much? What was the margin of error on his measurement? And what were the error modes that led to those margins of that margin of error?
The error modes. What on earth do you mean by that?
What are the things that could have
Well,
caused
what is
error
the
in
error?
what he measured?
The excess measured is greater than the instrumental
Hold on, this has nothing to do with
precision.
excess. This has nothing to do
Really?
with excess, Brenda.
Okay,
This
well,
is just simply
it's all
using
tied
just
together,
measuring
though,
the
Rumpus.
horizontal. He's done it. He did it.
No, if
My
all we
God,
do is
No.
measure the
God,
horizontal, we
Brian,
get pluses and
stop
negatives.
interrupting
Brian,
people. I just got
hold on.
two words out of a sentence there. He demonstrated because the auto levels, or theodolite he used, has a horizontal and a vertical. And so because you know the horizontals don't match up between two positions, or you're getting, perhaps you were referring to excess in the terms of there's a diagram. I think, yes, you were showing the diagram earlier, weren't you, Brenda, of the sum of the angles.
Yeah, I'm probably using the word in excess incorrectly, so I apologize for that. But the point is that the observed deviation is greater than the error, the tolerances of the instruments he used.
Correct.
How much was the deviation? What was the distance between these 2 points here?
I think he did it over a couple of miles, didn't he? Certainly, Jesse did.
That's kind of the information you should have to hand right away if somebody asks for it. By the way.
Well, okay, I don't happen to remember what Main Surveyor did off the top of my head.
So what is the
It would be interesting to take
difference
this
in
data
the
and make a
angle between
prediction.
the two at 2 miles, Rumpus?
Right. It would be interesting to make a prediction and say,
Well,
given these angles of these
No, it
plumb
wouldn't,
bobs,
because the
distance
error
would be
modes
X,
between 2
and then
miles
verify.
through the atmosphere is going to swamp out any hope of measuring this tiny
Right,
deviation.
that's called
that you're
numbers, so
looking
we can
for.
make that prediction as well.
Shut
So
up,
we can-
Bo, dude, you dishonest fuck.
Yeah, I know. Perfect time to
Right,
interrupt.
so-
You're doing great, Brian. So
what
it
you're
would be
claiming,
interesting
Brandon,
to make
basically,
this
I'm just going to
prediction.
point out your dishonesty. Sorry.
So, Brandon,
know,
basically
spiral
what you're
more.
saying is the refraction error, or the effect of refraction, is greater than the curvature of the Earth. That's basically what you're saying.
The refraction, yes, is so tiny, 2 miles, that
Yeah, but
the
there's also
refraction
refraction over 3
error,
miles as
not
well.
to mention the fact that on your model, there's different gravitational potential at different points in time on the Earth. So did he rule
That's
out
irrelevant.
the idea that there was some other influence on the plumb line at those?
I mean, you only
areas,
get the sort
or-
of effect.
They have to
you
use
only-
terrestrial refraction to get it right.
Right.
Yeah, I don't
Will you
think
admit that, Rumpus?
Did he? Well, hold on,
we
Brian.
use standard refraction, Brian.
Oh,
Yeah,
so
for
standard
standard
refraction was factored in, so there was a calculation done. It's not just a straight measurement.
I believe he allowed for refraction.
Where'd you get the R
Yeah.
in your
So
standard
you
refraction
have
from?
calculated that 2 plumb lines are not parallel. You haven't measured it.
Well, no, we can. No, we have.
ding,
We
ding.
can- if you use the observation that he made, the real world empirical observation, that shows that the 2 plumb lines are not parallel
No,
because the
not if
horizontal.
he corrected
Hold on,
using
let me-
some kind of
let me-
standard
let me finish.
refraction.
And the
calculated.
refraction,
No.
the refraction just makes it
Idiot.
less. That's all.
No.
Sorry, makes
no.
it more. Allowing for the refraction is still a smaller factor.
That's
not
difference
true.
Between,
Not buying
yes,
it.
it is.
You
That's not true.
calculated.
Understand what-
You calculated and assigned values to variables that you did not measure.
Just say
yes,
Rumpus.
That's a bit of a baseless claim, isn't
I
it?
assumed
No, it's not.
he used standard refraction.
No, it's not because
They're not
you assert
honest.
it,
They won't
you
say
assert
yes,
it with
Rocky.
emotion.
They're just
What do
not
you mean?
honest.
What is being measured here?
a
Why are the numbers there? Are you saying that it's pure calculation with no measurements?
There's a reason they have to calculate in refractions because they're doing distance measurements with tools that are optics in the atmosphere. So they have to calculate refraction. As soon as you do that, then you can imply whatever you want.
The
No, I
refraction
just wanna-
you can't do that.
refraction reduces the effect. So by allowing for, so visually, the fact that we still have this difference means
Keep it
that we have
honest.
my God, Brian, we have an.
I'll shut up. Just keep it honest.
Jesus
We know you're not
Christ.
going to, Brian.
Take
Stop
your
saying
turn
that.
for Christ's sake. Learn some manners. So we have an observation in which we can clearly see the horizontal from one auto level doesn't match, or the excess in angles. If they're not the same, if they're at the same level, then you don't have to make this calculation that the allowance that Brenda did in her diagram. But if you have the 2 auto levels at the same level, the same elevation, then you don't need to worry about that. And then you can just see that your 2 auto levels do not point at one another. Now, the refraction actually makes that effect less, not more. So we
you're not
have
you're not talking about plumb lines having excess, right? And triangles being more than 180 degrees now.
No, we're
are you?
not talking about that.
You're talking about something different now?
We're
Rumpus,
talking
how?
about Jesus Christ.
Let me
Brian,
ask you a quick question.
answer back here. Let me answer back here. Right.
Go ahead.
No, because the excess, we normally talk about the spherical excess, we're normally talking about triangles. But when we're talking about this observation about 2 auto levels pointing well, there's a different excess. We use sometimes use, I think it's.
Yeah, you're talking about refraction.
Well, hold on. The
7/6R, correct?
Oh, Jesus Christ. If Brenda would like to show a diagram again, we can see what happened. If you want to just talk about when they're the same elevation, it makes it a lot easier. Basically, oh my God, 2 auto levels at the same elevation do not point at one another.
Yeah, why?
Of the Earth is curved.
Because of refraction.
No, the refraction makes the effect
Because you're
less,
looking through an optic
not more. The
over distance.
refraction makes the effect less.
Okay, how
more.
much human error is in your setup? How much instrument error is in there, and how much refraction did you calculate to show
that a model,
He used standard refraction.
this
but it makes the
diagram.
effect less. Brenda, what are you trying to say to me?
Brandon is sharing the diagram.
Oh, is he?
Yeah, let me ask Rumpus my question. Rumpus, let's say I look a mile away through an auto which is already horseshit, okay, and I see that it's 2 foot above or 5 foot. I'm marking with my story pole. Okay, when I go 2 miles off in the distance, okay, how am I going to know if my auto level is higher or lower than the spot that I just left?
How would it be higher?
Right. Well, the simple way to do this is to put your auto level. If you find a body of water that's 2 miles long, and you stick an auto level with the same leg, the same distance above.
Oh my God, Rumpus!
Oh my
give me a real life answer.
My goddamn sentence.
No bullshit! You're not gonna tell me next to a
Brian, come on, man. Brian, chill,
trying
man.
to eliminate all the crap you introduced.
Okay, but he put me next to a body of water, Brandon.
Right.
I know, I know.
Oh God.
Brian, I know you're angry, bro.
Jesus
but control
Christ! Let's just
yourself,
finish
bro.
the answer here. So if to eliminate all the issues of staffs and things and complications of elevation, just simply imagine a body of water that's 2 miles long and you have the same leg, you have the same height of your auto level, and you stick the leg in the water and you have that 2 miles away, you stick the leg in the water there, so they're both exactly the same height above the water. They look at one another, they will not see one another as horizontal. And that's because...
So you think they carry around bodies of water? Is that what you think, Rumpus? How do they do it when there's no bodies of water, Rumpus?
I was just simplifying the situation so there's no confusion about topography. If we can just concentrate on the scenario I described, it simplifies the argument enormously, and we don't have to deal with it. We don't have to deal with the complications you keep on trying to bring in. Why don't you accept my analysis? Why are you dismissing what I just described using a body of water?
Because surveyors don't carry around bodies of water, pal.
I'm saying go to that situation, and then that exposes the phenomenon. Without
he can stall only once. He's never going to get the answer, people. Listen, I'm going to ask you one more time. If I shoot out 2 miles in the distance and I read 5 foot in my story pole, okay, and I go
around, you're very distorted. It's very difficult to understand what you're saying. Can you say it again slowly so that I can understand what you're saying?
Okay, I shoot off. Let's just make it a mile. I shoot off a mile, okay, and I mark my elevation, okay, and now I move shop. My story pole. Hold on, my story. Hold on, let me answer the question. Let me ask the question.
I don't understand.
I just asked him not to interrupt you. You got to let him.
Yeah, but he doesn't. He misses out so much information. I can't understand what he's saying.
That's
okay, I'll start from scratch.
About you, Rumpus, that you were changing things and he didn't like it, and that's why he was interrupting you. So just let him.
I'll start from scratch, Rumpus. Okay, I set up my auto level. I send my story pole guy out 1 mile. Okay, I set up my feet are touching the water, but the water ends right there. Okay, now I get a mark. Okay, arbitrary mark on the story pole. Okay, I mark it on my piece of paper. Now I walk a mile forward, and my story pole guy goes a mile off in the distance. How do I know if I'm higher or lower than the spot that I started from?
Well, who cares? That's not what we're talking about. We're talking about 2 auto levels.
Because if I'm going to prove a globe,
no, wait, but why deal
if I'm going to map it on a globe, I'm going to map that I'm curving.
You're dealing with another situation. Brenda and I and others have been talking about when you've got 2 auto levels pointing at one another, not a staff. So why you're introducing this staff scenario is utterly irrelevant.
They don't use 2 auto levels pointing at each other.
Yeah, but we do in this situation as a test situation. And what
so first you want to move a body of water along with you.
The surveyor did this. And so
first you want to move a body of water along with the surveyor.
Because it simplifies the issues and we don't have to worry about staffs and recording things on pieces of paper.
All right, ladies and gentlemen, I know I'm a bit high,
levels are pointing
no
at
idea
one
how to
another. They do not show one another as being horizontal. And then we can avoid all the issues and complications you want to introduce with staffs and poles and notepads and things. And we've got a simple scenario we can talk about.
Hey.
Okay, I apologize for being hot-headed, but so, ladies and gentlemen, what Rumpus does is he thinks that the surveyor is for simplification, bringing a body of water along with him, or he thinks that they're going off pointing auto levels at each other. Rumpus is a retard, people. I rest my case.
You are a moron of the first order. You can't realize what I'm doing here is to make a simple scenario that even you would understand. I'm trying to eliminate I'm trying to make sure that you understand the auto levels at the same height by talking about a theoretical scenario in which we were dealing with a body of water.
No basis in reality.
Rumpus, how do I set up an auto level, Rumpus? Rumpus, how do I set up
a scenario because it wrecks your argument?
How do I set up an auto level, Rumpus?
In terms of calibrating it or positioning its elevation?
How do I do that?
Well, you can. if you want to do what Jesse Kozlowski did, he measured the height of the auto level, the center of the optics, from a body of water just next to it, using.
No. It's real simple. How do I set up auto level? It's real simple, man.
Well, when you say set them up, you're talking about calibrating them using a 2-peg test.
Ladies and gentlemen, I give you Rumpus the retard.
Well, you're a moron. Okay, if you don't, that's all you're going to say.
What you do is you set it on the tripod. Okay, you set it on the tripod, and then you level it out, and you get if it's an auto level, it's going to have a bubble of air in the middle of water, and you adjust it until the bubble is in the center. Okay, you did not know that. That's the only answer to that question, pal.
It wasn't worth mentioning.
It doesn't involve water because the legs don't matter. You can have the legs fucking like they ain't even drank their V8 yet and still get the auto level.
But the point is, we want to know these two auto levels at two ends of a 2-mile body of water are the same height above the water. That's what we're trying to achieve in the scenario I'm describing and Brenda was describing.
That's abusing the tool, Rumpus.
Sorry?
That's abusing the tool. That's not how it's used. There's no point in doing what you're saying to do. No, there's no point.
It's not abusing the tool.
Finish.
We're not making any inaccurate anything.
Let me finish. If you're shooting that auto level out more than 50 to 100 meters, then you're using the tool incorrectly.
Wrong. You don't know why.
Exactly. If I asked Rocky that same question, that would be the answer he would have given me.
You don't understand why that is a procedure. And the reason is because of the curvature of the Earth. That's why you don't understand. The tool is the graticule you see in a theodolite or an auto level is perfectly accurate.
Two different tools.
Except for
those are two different tools.
You can use a theodolite as an auto level.
The auto level doesn't care about the shape of whatever you're on.
There's nothing inaccurate
Jesus
about that
Christ,
line.
man. Somebody else who understands this shit.
That line defines the horizontal as an infinite plane. The reason you don't use auto levels and other theodolites over great distances is because of the curvature of the Earth. And I'm going to do a video about this because it seems to be such a problem, even people like Rakia and Brian, who use
people who use auto levels their whole life, Rumpus.
Understand why they
people
use
who've used them
All
their
right,
entire
we'll let them
life,
address
Rumpus.
that here in a
the
second.
basics
Brian,
of
do that
using
thing
an
with your
auto
mic,
level.
will you? Please.
You don't use those tools that create perfect
Who are you talking to,
horizontal.
Brian? Brandon, me or Brian?
Rumpus,
Brian.
you don't use those tools out of their order.
No, they're not. You don't
Hold
understand
on, I'll let you guys
why.
continue this. Just please. Ricky, I'll give you the floor in just a second. Let me just read these two super chats. Will Gaston. Yep, I said, Brenda, do you speak for all globe believers? You like to use we a lot. Brenda, do you think you speak for all globe believers?
We is sort of just the collective people who have who understand science and facts and reasoning
and geometry.
Oh, that's nice. All right, thanks, Brenda. Thank you, Will. Godzilla 37, shout out Godzilla. A baller can either be honest or a baller, but not both. Straight is not curved. The shortest distance between any 2 points is a straight line, and Brenda is still a POS. Not sure what POS stands
People
for.
have got
Thank
the
you
problem.
very much, Godzilla.
If I gave you a basketball and I said you're only allowed to move on the surface
I was going to
of a
get the floor,
basketball,
Rumpus.
and you're only allowed to move on the surface of a basketball.
Rumpus.
Maybe you missed that part, Rumpus.
Nice try, though.
So, Rumpus, these tools are very specific. They're manufactured and designed by smart people, of course. They've been developed, tested, and they're tested in certain ways, right? They're tested under optimal conditions, which means when they say they're good for this measurement over this distance, it's optimal conditions.
Do you use these tools?
I'm sorry for cutting me off right in the middle. I'm almost done, Brenda. I promise you, I'll be really quick. So when you use these tools beyond those capabilities in conditions that aren't optimal, then you're going to get less than accurate measurements that they're dealing with. When you point them at each other over distance, especially over water, and you're going to tell me you don't understand how they're not like perfectly lining up with all the human error, mechanical error, refraction, diffraction. I mean, come on, man.
The effect is much greater than the error.
So do you use, Rakia, do you use these tools professionally?
He claims.
You mean did I use these tools today?
Do you use these tools?
Are you asking me if I use them today?
Yeah. We know, Brown.
Yes,
we know,
I use them all.
Yeah, but he doesn't. But he doesn't. Only uses them in a simple way because he doesn't understand.
Auto level. You want me to put him
How
live?
have you used them, Rumpus? Explain to us how have you used them.
Could I respond to his points? Right. So he doesn't understand why you use an auto level over short steps, and I did explain to him, but he's ignored it. The fact is the curvature of the Earth. That's why you do it, to avoid the difference between the
to avoid the refractive effect. No, it's to minimize the refractive effect of an optical tool.
Curvature.
No, that's a lie.
The refraction is a smaller effect.
Don't lie to me, Rumpus.
You don't understand.
The reason these tools are used over short distances for accuracy is to minimize the refractive effects of using an optical tool.
There's another issue.
Maybe we should ask one of the manufacturer's manuals why they do that.
Yes, and they
talk bring up one of the manuals for an auto level, and maybe the manufacturer would actually tell you in the manual why they are only limited to a certain distance.
They do not dispute that they give you a horizontal over an infrared plane. They don't dispute that part of it. But the point is, the graticle. I mean, for instance, let's imagine a scenario in which you use the auto.
No, let's not imagine.
Can I just finish?
Let's do what every
rude person.
No, I'm not being rude. I don't want to imagine.
Point here.
Yeah, you're trying to get us to imagine.
Be quiet. If you
no one plays your game anymore, Rumpus.
Be quiet.
Yeah, don't call me a twat, sir.
Be quiet, twat.
Yeah, I'm not going to be quiet if you're going to call me a twat and tell me to imagine things. I'm interrupting you because you're calling me a twat and telling me to imagine. Your first word out of the three was "let's imagine."
Censor me, you little twat.
No, you said let's imagine.
Didn't you?
Let's not imagine.
Tried to stop me making a statement.
How about let's not imagine?
That makes you a twat. So
how about let's talk about you using an auto level in reality?
Be quiet.
Let's don't imagine we use an auto level.
You don't.
Let's not imagine how they work. Let's actually talk about how they do.
I'm about to give you a scenario in which an auto level does have a limited accuracy. If you
do we have to imagine this?
If you were to look at the moon through an auto level, the size of the graticule on the moon would be.
Who the hell would look at the moon through an auto level?
Would be covering 10 times. So that's what they mean by the accuracy. And similarly, if you were to use an auto level and you wanted to use it to say define the size of, I don't know, the level, the accuracy obviously is going to decrease with distance, just because the angular size of your graticule is going to be multiplied by your distance. So if you want to
refraction,
but the accuracy of an auto level is something like, what is it, a millimeter or something over a over 100 meters or something. So but surveyors don't work to accuracies of a millimeter over 100 meters. So it's not the cause. It's not the cause of planar surveyors only using them over 50 meters or so.
How long does this guy get the
cause because the accuracy is millimeters. What is the cause is the curvature of the Earth, and Rakia doesn't understand it because he has never read he doesn't read any surveying books. He has never read a surveying book. He doesn't have any surveying qualifications. But
he's used them his whole life, you jackass.
So he doesn't have no surveying qualifications, and he has no. He does not.
Tell the audience what I've done.
It wasn't in a bag. There's a box.
I'd like to know how Rumpus does what I've read.
Experiment from main surveyor.
Okay, I'm lost.
You know, Rakia,
those are all A's. They say A, right? That's an A. That's a ray.
That's a ray.
Oh yeah, they're all a ray.
Oh, good for you.
Go ahead. Rumpus is
I
muted.
was getting a lot of background. Was that
I think that was Tony. I think that was Tony.
His mic must have been open. Tony, your mic was open.
Oh, okay.
That was a retard Tony V, ladies and gentlemen.
Could I just ask whether that was Brenda who presented this main surveyor?
Brenda is the one who provided this diagram, yes.
Can I just ask why she provided it? Because this exact video makes the radius of Earth about 2,700 miles.
Oh. Interesting.
Also, Brandon, real quick, the error margin for, let's say, a simple auto level over distance is plus or minus. It's not just minus like Rumpus is saying. It's plus or minus due to conditions you're looking through things.
And it's also not just one error. It's several different errors combined to be plus or minus.
Well, notice when I asked what the error modes were, they acted like, oh, what error mode?
Can I say one thing about the
That's a
error?
stupid question.
It's,
Can I, Brandon? Let me just say one thing about the error.
wrong.
Hang on. The error is horizontal, so it's your plus or minus off of horizontal. Horizontal is the error. So when these people don't understand that horizontal is perfectly level. Level
It's a vertical
is
change.
horizontal.
That's not what horizontal means.
Whatever.
Please tell us what it means, Brenda.
It means perpendicular to Plumb.
Yeah, there you go.
But anyway,
The
sorry,
next words out of
Brenda.
her mouth.
Gleam, we
Let
stepped
Gleam.
question
Yeah,
to
Brenda, why does the circumference, the radius, if you look in the general chat, I've put the screenshot up of the exact video that you got that from. And it says it's 2,718 miles, which means it was 68% correct or 32% incorrect.
I don't know. I don't know where you got those numbers from and whether or not your
his video.
calculations were accurate. Did you really?
Your
video. Surveyor.
That's the main surveyor. I know the main surveyor, and I will actually salute him
from?
because he's
Imagination?
one of the proper ones who actually goes out of his way to actually account for errors.
So
I
how
will
do you
say-
how do you account for the fact that he observes that the plumb lines are not parallel?
The whole thing is there's errors there.
Wait,
Yeah, but
calculated
how do you
that,
account?
Gene.
How do you account for that?
Yeah, the core thing is it's inconclusive if it's got a 32% error.
No, it's not.
In science, you expect
not.
a 1 to 2% error.
It's not. So how do you account for the fact that the plumb lines are not parallel?
Because of error
Well, there isn't that much
in
error.
measurement and
The
calculation.
instruments don't have that much error.
Well, how has he made that much error?
He hasn't. You haven't shown error.
I've just showed the screenshot. Do you want me to post it again in the general chat? Brandon, do you want to bring it up?
Yeah,
It's
the
in your
errors-
inbox.
Yeah, that's not showing an error. What's the
I'll
error?
Yeah, it says blatantly there. And he says in the video, he says, yeah, this obviously is not correct for the radius of the Earth. It's well underestimated and it's too short to calculate at all.
So what?
Like to add that
So-
Bob, one of your
you're
great
using it
guys,
to
had a
prove
So
that
what?
there is a radius of the bent surface,
he wasn't
but the
trying to ma-
radius is only 68% correct.
So what percent of the diameter, actually the circumference of the Earth is a couple miles? Because one
Yeah, are
station
you not
was a
getting
couple.
what I'm asking?
No,
Are you not
one
getting what I'm
station.
asking?
Yeah, it's irrelevant. One station was just a couple of miles from the other one, right?
Yeah, you're not getting what I'm
Right?
asking.
No, but
the
just
plumb
answer the
lines
question.
are
Just answer the question.
No,
They
you're
were
the
only a
one who
couple
has
miles-
failed to answer my question.
They were only a
And
couple
you're
miles
distracting
apart,
by
right?
asking me questions
No,
now.
I'm not
No, listen.
distracting. I'm
are.
addressing your claim of error. The stations were just a couple of miles apart, right?
Yes.
Yes. So out of the circumference of the Earth, what percentage is 2 miles?
A
Which Earth?
very tiny percent.
Which Earth are you
Yes.
talking about?
Therefore, any errors, any instrument errors are going to be magnified over the 24,000 miles, which is the circumference.
Which is
of the
my
Earth.
point.
When was that
Which is
measured?
my point.
It's irrelevant because
which is
he's
my
not
point.
he's not measuring the
When do you
circumference of
ever-
the Earth. He's
Okay.
measuring. He's showing
Okay.
a. Listen,
Yeah.
listen. He's
What
showing
is measuring?
He's showing a logical contradiction.
No, he's not. Not if he
The
doesn't have a
logical-
globe to work with.
No, the logical contradiction
No.
is that on a flat Earth, plumb lines
That
will
you're
be
imagining.
parallel. Just a minute. Here's the logic. On a flat Earth, plumb lines will be parallel. Plumb lines are not parallel. Therefore,
Why-
it cannot
why
be.
would
No, they wouldn't because of error.
Can I ask why
So
would
in
they
a-
would be parallel on a flat Earth? Sorry. Why would
Yeah,
that
why
have to
would
be?
they in a sandbox?
Because perpendicular to a flat
In a
plane
sandbox?
Yeah,
would
that's
add
with no
to
error.
90 degrees, would be 90
That's with
degrees.
no error, Brenda.
Is it not
You're
center
talking
of
about-
mass?
You're talking about on
You're
the surface
talking
of
about
liquid.
gravity, aren't you?
No,
Is it
I'm
not center of mass?
You're not even understanding the logical argument I am making.
You're talking about something with no
It's
error.
illogical. That's why.
No, it's not.
It is because you're not explaining how.
Yes, I know,
flat
because
Earth
you're
has gravity
incredibly
just
stupid.
going all the way down,
You're
right
incredibly
the way to
stupid,
the edge.
Clean. You're very stupid, Clean.
Oh, turn to ad
Why are
homs.
you going to that, Brenda? We're having a nice conversation, a nice back and forth, and all of a sudden you're calling.
Are we all stupid,
Why are you
Brenda?
doing that?
Okay. Conversation over. Thanks.
I call it
Yeah.
projecting.
Point is,
Game over. Ding, ding, ding.
So
We
the
have a
point
winner,
is-
and it's not Brenda.
point is, it is a logical contradiction. On a flat Earth, we expect plumb lines to all be parallel. They are not parallel, therefore it cannot be flat. It doesn't say anything about the curvature.
Did you mention error there? Did you mention error at all there?
The error of the instruments he uses are
What about
well
human
within
error?
the measurements that he made.
What about human error?
The error of the instruments he uses are
What
well
about human
within,
error?
they're well within the
What
measurements
about
that
the
he
human
made.
error, Brenda?
They're well within the
Was a
measurements he made.
human using this instrument,
So it's
Brenda?
all well within the instruments that he used.
Are the plumbs separated
Yeah.
by Earth curvature, the radius of Earth?
That's not the question. The point is, it's I'm saying a logical
I know.
contradiction.
I shouldn't
of
have come back in. I'm sorry.
But it's a logical argument.
So there's
It's
no
a
You sound
logical
desperate,
argument.
Brenda. Are you desperate?
So the point
You're
is,
talking about something you don't even know about. You've never done.
yes, I do.
You're going by a human using an instrument and only talking about instrument error because it fits your little desperate model. You sound really desperate here.
No,
Was a
so the
human
measurements-
using the instrument, Brenda?
So the measurements are within the tolerances of the instruments he used.
Is it the simple questions that get you? Because you've said that 10 times without
No,
answering my question.
They're irrelevant questions.
The human error is irrelevant?
The instruments have tolerances.
Yes, we know that, Brenda. You've said that 10 times. We agree.
So the measurements
plus or
that are
minus.
observed, the measurements that are observed are within the tolerance of the instruments he used.
So show us on a sphere how that works. Brenda,
He's just roboting. He's just
Get on
roboting.
top of a sphere and show us how that all works.
So
with your
remember,
plumb
this is a logical argument. On
I
a
would just
flat
talk over
Earth,
him and just completely ignore what the guy said to you. How
do you
rude.
understand? Do you understand that on a flat Earth, all plumb lines must be parallel?
No
They are
error.
not- They are not
No
parallel.
atmosphere.
Flat water.
They are
Are you
not
using
parallel.
an optic on a flat Earth to look through the optic
Your
through distance in the
desperation-
atmosphere?
your
And you're saying there's
desperation
no.
is palpable.
Oh, so now you're using desperation. Didn't I
So you're
give you that
desperation.
desperation?
I'm not
How
desperate.
is talking about optics through the atmosphere causing an error desperate, Brenda?
Is there some other way of viewing things other than optically?
No.
There you go.
Not that
Do
I'm
you have
aware of.
error? Do you have error when you use optics through the atmosphere over distance, Brenda?
The standard refraction? Yeah, that's taken into account.
Standard refraction.
Yeah.
Give us that formula, please.
Oh, you know it.
Oh, do you? Do you know it?
What does that have to do with anything?
Because it assumes an R in there, Brenda.
Standard refraction does not assume an R.
What's the formula?
Then what's the formula?
Is it a calculation? Let's say it doesn't assume R. I'm fine with that. Let's say it's over a flat Earth. Is it a calculation, Brenda? Just say yes so we can move on. Yes, it's a calculation, right? Why do we have to calculate refraction while using an optic through the atmosphere, Brenda? Maybe to calculate the error caused by the refraction? Do I sound desperate now, dear?
Very desperate.
Yeah, well, I'm eating Chips Ahoy and milk. Doesn't seem very desperate to me.
Yeah, I should actually have supper here pretty soon. So standard refraction.
See you later.
Did you find the equation, Brenda?
I haven't looked it up. Because it's
okay.
irrelevant.
It's
irrelevant.
okay. We don't need it.
It's
Yeah, we're good.
it's
So
irrelevant.
Silent Zero
These
says
are just
$5. Now Rumpus is telling people how he used the tools. Rumpus is such a bad person. Thank you, Silent Zero.
Yeah, he's a lying sack of shit when he wants to be.
Yeah, I mean, it's not as if something like a 2 mile away horizon could be pushed back 15 miles. That's impossible, isn't it?
So, are you going
No
to
way.
are you going to explain to me, Gleam, why plumb lines are not parallel? This is
No, because
observably
you're just going to call me
measurably.
stupid when I ask you questions.
Oh, you can
What's the
cry
point?
harder. You can cry harder. People call
There's
me
no
names.
crying.
No,
I
people
won
call me
ages
names
ago.
all the time. People call me
She's
names
right.
all the
She's
time.
Yeah, other
right. I
people,
call her
I don't
turd
need
burglar.
to.
Toughen up, little
I
boy.
don't need
Toughen
to.
up, little
I
boy.
don't need to.
Get a thick skin. Get a thick skin,
Listen
little
at you.
boy.
This is where you have to go, Brenda, right? This is where you have to go because you're getting demolished.
Man
Can we
up,
stick to
little
the
boy.
argument? Can
Man
we
up.
stick to the argument
You're
until
not a
you
little
call
boy, Brenda.
other
Wasting my
men
time.
little boys?
You
Is this
can't
your
be.
fantasy?
You can't be
Wasting my
Is this
time on
fantasy hour for
grown men.
Brenda?
You be a
who
All right,
bad
let's
will
move on,
actually
guys.
call you
Let's move on.
names.
bad.
Let's move on away from Brenda. Let me change the subject here.
Yeah, we're
Because you're
all men
stupid.
here, right?
All right, guys. Let's move on.
No,
I've
you're
got a
betas.
question for you
You're all
guys.
betas.
So,
You're all betas.
Says the turd burglar.
Yeah, Brenda's
All
the
right.
alpha male
Anyway,
here.
so let me ask you guys a question. There's
I'm
an
just messing with you, Brendan. I'll go ahead, Brendan.
Can you guys hear me all right? Hello?
Yeah,
Hello?
we can. We can.
okay.
We can.
All right.
Yeah, definitely can.
Cool.
Yeah, I hear you good, man.
Yeah.
I had
All
to. I was just joking with her, but yeah, she can give it as well as she
Hold
can
on,
take it
Brian.
lately. I'll give her that.
Hold on. I'm trying to change the subject here because I'm kind of bored of Brenda. All right.
At
There's an
which end?
assumption.
Go ahead, man.
There is an assumption that gets bandied around quite often that the horizon will always rise to eye level on a flat Earth. And I thought we might discuss that because my understanding of this argument is that it doesn't matter how high you are above sea level, under this theory, 0, 10 feet, 100 feet, 1,000 feet, the horizon will always be eye level. Anybody heard this before? Does anybody?
Yeah,
any of the
I don't
Globers
believe that.
stand by this assumption?
I don't believe that myself. I believe it rises towards eye level. It appears to. It's just an optical effect. The horizon, if you're 6 foot off the beach, then your horizontal is always 6 foot above the horizon. But when you're that close to the surface and the sky is that much higher, it's just going to give that optical effect that it's rising up to your eye. As you gain altitude, that changes, and there comes a point where the sky will actually look lower than your eye. It's just an apparent position. It's just an optical effect. Horizon drop. Now listen clearly. All you ballers, horizon drop is not Earth curve. It's an optical effect. Thank you very much. Be here all week.
I think if the Earth was infinite, then you might get an effect similar to the horizon always rising to eye level, because there would always be land to replace the distance that you're seeing further. If it was like infinite, but I don't know. I don't know if we're capable of getting high enough to see, just how far it goes, basically.
Your eyesight would also have to be infinite to gauge that.
Well, yeah. I mean, you would have to be able to see through all the crap, obviously. Yeah.
We all know that's not what's happening. We're being obstructed, and things are being mirrored and refracted, diffracted, whatever, distorted over short distances. Much less when you gain altitude and looking 200, 300, 400 miles. Come on, a little common sense.
You wouldn't have a crisp horizon. You would have the land fading out with distance. That's what you would have.
I've never seen a crisp horizon in my life.
Oh, you lie now.
No, yeah. You zoom into it, it's hazy,
You're
distorted.
Your own picture, 2 boats, clear horizon.
Show us a picture of a clear horizon, Chucky.
Yeah, give me that.
If you have one handy.
I've looked out on it.
It's not mine, it's Rakia's.
Yeah, I've looked out on a clear horizon, a clear day, blue skies, just scattered clouds here and there, sun shining, just a beautiful day. And I look out into my horizon and it looks very clear and crisp and whatever. And then I get a zoom camera and I go out and a boat disappears like 3 miles away into the haze. Right?
Tell me the horizon in this picture is not clear.
You can't tell whether it's clear or not, especially by
I
a picture.
can. Yeah.
Oh yeah, yeah. You got this magical power, do you?
I see.
Are you the horizon
With my
god?
not so good vision, I see clear horizon.
Yeah, you see what appears to be a clear horizon. I'm very, very proud of you.
Horizon King.
Where the water stop and the boat stop. Clear.
Where it appears to stop. Okay, so give us some. Hang on, he wants to go down this route. I'm fine with that. It's cool using my picture because this tells me you know nothing. Just tell me one thing about that picture. Let's say, what was my viewer height?
I don't know. Only you do.
Okay, well that's strike one. How far is that first boat, the one that you say is so clear? How far is that boat away?
2.7 miles.
Okay, so how far is the second boat? If I give you 2.7 on the first one, how far is the second boat?
About 7.
Wrong.
So I'd say like 5.5 at most.
I would say less than 4. Definitely less than 5.
I'd say just under 5, 4.8.
The angular resolution seems to be.
Yeah, you can't go by that, sir.
I would about double the distance.
The island itself is only 7 miles long. And the oil rig that's past those boats right there is about 5 miles out. And on this day, hang on. On this day, you can't even see the oil rig.
Yeah, I was going to ask you, there's Anna Marie in the front, obviously, right? Then what is this to the right? Is that another boat or is that the oil rig?
It's the exact same shrimp boat. That's the exact same shrimp boat owned by the exact same guy. His name is Mr. Thibodeau. Had dinner with him and his family that night. We had shrimp.
That's a big name over there in New Orleans. Thibodeau.
Mirage that is obscuring this boat at the bottom. You can see the doubling on this other shrimp boat. So
what doubling?
This isn't a clear horizon.
Rocky, my brother went to college in Thibodaux, Louisiana. Man, I lived right there in New Orleans for, off and on for about 5 years.
Yeah, so, this is a phenomena that you know, people post as Earth curve and blah blah blah, and like Chike, but he knows nothing about the viewer height or conditions of the day or how far the boats are, you know, whatever.
So outside of this,
Brandon, can I share my screen real quick, Brandon?
We're just discussing what the horizon would look like on a flat plane, and I thought Bob Dole brought it up very well, where we wouldn't really have a horizon on an infinite plane, and then with a great enough distance, what you would see is not a horizon at all. It would just be a phasing out
exactly
of what we appear to
Is
see.
that with or without?
What I was saying is, if it was an infinite plane, then the horizon, I think, would continue to rise with your eye level because of the fact that there would always be ground to replace it if it was an infinite plane.
And we could see.
Well, even at a distance. So let's say at sea level, the air is the thickest. So even on an infinite plane, you wouldn't be able to see infinitely. It would be due to what's in the air. So let's just say it's 100 miles. And then that's when the air is too thick to see it beyond that. We know that 100 miles.
Hey, Brandon, can I share my screen real quick?
Visibility is usually like 8 to 10 miles, but go ahead.
Right, which is fine. So even whether it's an infinite plane or not, on a flat Earth, the horizon or what we can see would always rise to eye level until it would fade out because of the atmosphere fading it out. We would never have a horizon.
Okay, but like the fade out wouldn't affect what you're seeing because all it would do is shift forward the apparent meeting of the sky and ground. That would just be something that you see closer to you, which is like it wouldn't matter where it disappears at or where it fades out at. All the horizon is an apparent meeting of the sky and the ground. So wherever that happens, it happens, whether it's close or far.
Right. But we would never get. That's why I bring up the point of the crisp horizon, because we have a crisp horizon because we can see farther, but we don't see beyond that surface because it's being cut off because it's a curved surface. On the other hand,
because it's just being distorted. You're not getting that information.
On the other hand, on a flat plane, what we would see is the land extending, always approaching eye level, and then what we see at a distance would be fading because we're seeing through more atmosphere, so it's more obstructing, but it's the atmosphere obstructing. So
If
it's
Brandon will
fading.
let me share my screen, I'll show you an auto level. We can look through an auto level right here, right now, if he'd let me share my screen. I don't know if there's too many people in
I'll
here.
tell you why he's setting up real quick. One thing that happens as you're going away, let's say 10 to 12 to 14 miles, depending on the day, I have water towers on the beach, and you can see the top of them. You can see the tower going down to the ground, and then the ground gets cut off. The camps that are off the beach behind the levee are being cut off, of course, by the levee first, and then you can't see the roof. And then all of a sudden, the white water tower just blinks out. It doesn't disappear bottom up and disappear. It starts to disappear bottom up, and then all of a sudden you get to a certain distance, and it just fades away. It just vanishes. Blink. Do a blink, and it's gone. Turn around, go. What do you mean, do I have a video? You can go. You don't need my video to critique. You can go do these things yourself.
You're talking about an observation that you have. So I was wondering if you had it to present, or if it's a personal experience that you can't share.
No, it's an experience that anybody can do, and you shouldn't trust me. You should go out and do it yourself. Just walk away from the object, especially over the water or sea, and see how something. Pick the tallest thing, the most bright thing, usually something white, right? Because the white light you can see further than, like, let's say green or gray or blue.
There's no relationship with that. But
yeah, well, I'll take that.
Sometimes it has.
I'll take that.
I agree with Rocky.
You think you can see a tree the same height as a white water tower?
Because the water tower is fucking bigger, Rikia.
No, I'm talking about a tree, like a group of trees, right? The same size as the water tower.
If it's the same angular size horizontally and vertically, but different colors, you're going to see them for the same amount of distance.
You think the surface of a tree reflects the same amount of light as a blunt?
He's never done long-distance observations, Rocky. He's never done long-distance observations. He doesn't understand what we're talking about.
You know why we only see one of the Marriott hotels over the Lake Ontario? Yeah, let me ask. I will.
Keep continuing. Yeah.
Yeah. Well, put yourself on mute, and I'll ask my next question. You realize why we only see one of the Marriott hotel structures right there together from 24 miles away? You only see one of them at a time because of the angle of the light, sir. There's three structures right there.
I thought it was the color.
Well, it's reflective glass. They're all the same color, but this time the angle makes the difference.
How about you reform your thoughts, come back, and then let me know whether it's color or
how about my thoughts are real thought out and real precise, and I'm destroying what anybody can ever say against this.
I know you were bringing up color, and then you had
and now I'm talking about angles. Can you handle two things at once?
No, you can't handle.
You denied that color. You denied that color made a difference. You denied that the type of surface makes a difference in reflecting light, and now you're denying that the angle. Are you denying these things?
The type of surface, kind of. But
are you denying these things?
The specific color, no, it makes no difference.
So does the angle?
Of course, the angle does. Yeah.
Does the surface?
That's what I brought up. That's exactly
what
I brought up.
Does the surface, the texture?
Kind of, yeah, that would. Yeah.
Kind
of
have
an influence, yeah.
That
would have an influence.
A tree or a mirror doesn't reflect light differently? Wouldn't a tree absorb the light and not reflect it, and a mirror would reflect it more than absorb?
It absorbs. What is it? It either absorbs green and gives you green, or it absorbs all colors but green. That's why you see green, something like that. But the specific color has nothing to do with the distance that light will travel, or anything like that. That's what I'm saying. The color makes no difference.
Okay, but you're agreeing with the other two, right?
To a certain extent, yeah, one more than the other. But
so then a tree, the same height as a water tower, would disappear first.
Oh no! If they're the same, what
about the surface?
I could answer, right? I could, right?
You said no. That's an answer.
I'll treat you the same way I treated Brian.
I'll treat you. You answered. You said no.
In which you're allowed to finish, and a universe I'm allowed to finish.
So the answer was not no.
Right now,
was your answer not no?
Could I get out more than one word, Rikia?
Well, no, that was a good answer.
No,
I asked you a very simple question. You said no.
I need your permission. Can I get out more than one word?
Or you want to answer no and then yes? Do you want to change your answer to yes?
No, I'm clarifying.
Do you want to change your answer to yes, or are you going to stick with your answer?
I'd like the opportunity to clarify. Do I have your permission, Rikia?
Sure, but let me ask the question again, so we all know.
You gave
No,
me
because you
permission, so I'm
answered
gonna
and then
clarify.
you rambled on about not being able to answer when you
I'm trying to
clearly
clarify.
answered no.
I'm trying to
Yeah, I'll
clarify.
clarify the question. A tree the same height as a water tower,
Yeah,
which are different
that
surfaces,
bitch.
which
So
one would
far.
disappear first? The tree?
So I'm gonna clarify. I'm gonna ignore everything you said. I'm gonna clarify. So
What's the question then?
my
Can you state
no
the
no.
question?
I just told you I'm ignoring you. So my
Before you clarify, say the question again.
what would disappear first, the surface texture of trees or surface texture of water tower? So my clarification is if they are the same angular size horizontally and vertically, and pretty much the same position, so same distance from you, that one's not going to disappear before the other.
So
It'll
the
be the same
reflective surface of the water tower is not going to disappear after
No.
the tree disappears. That is absorbing the
No,
light.
it'll be the same time. Same time.
That's foolish. I'll
Okay,
take
well,
that bet.
good for
You want
you,
to bet? I'll take that bet.
Maybe.
Yeah, that's what I thought.
No.
I would back you up on that bet, Dave.
I'm trying to think of real world experiences.
I'll let
No,
you double the angle size.
no,
I'll let you.
here you go.
I'll let you make the tree twice as big and twice as tall.
Oh, then I would take that bet all
How about that? Okay.
course,
Well, let's.
of
How
course I
much?
would.
How
So
much?
at the same distance, twice
Yeah, same
as wide, twice as tall. And you're saying
Yeah.
the tree will disappear first?
Absolutely.
I'd still
Please,
take
someone
that
clip
bet,
it.
Rakia.
Please someone clip it. Yeah, I'll put $100, Rakia. How about that?
$100. How are you going to go do this opposite? How are you going to go prove this?
Oh, I don't know. For $100, I would put energy.
You're gonna have to spend more than $100 to go prove it.
You gotta find some water towers. I'm sure there's lots of water towers.
Anyway,
I live in Texas. A bunch of water. Do you want to take that bet? So double the height, double the width, the same distance, but the tree disappears first is your position, right?
Sure. Prove it. I'll give you $100.
Hold on. So $100, deal, right? Deal?
Yeah, deal. Handshake.
All right, perfect.
Done.
All right. Yeah, of course. Yeah,
Hey, good
All right.
luck.
Yeah, we can move on now. There's no use.
I'll bet another $100 you can't prove it.
I was gonna say, I bet you $100 that we never find out.
And then I'll bet another $100. I'll bet another $100 you never do it.
Hey,
How about that?
Rakia, remember when Chemo made the same claim and then I shit all over flat earthers with my experiment? I don't know if you want to take that bet, man.
Hey, bro,
you don't know how stubborn I am.
Let's see that experiment.
You don't,
I
you
just
don't know
want
how
to see it.
stubborn I am.
All right.
Hey,
Anyway, so
yeah,
Biodule, you said something about there being a crisp horizon. Now, Chaiki has provided one picture he thought showed a crisp horizon. That turned out to have a mirage, obvious miraging. Do you have an example of this crisp horizon that you think is evidence of something?
Professor Phil's GIF. Professor Phil's GIF is a good one.
Where is that?
It's almost any horizon. Almost any horizon can be described as a crisp horizon because we see water and then we immediately see the sky.
What about this one that I'm
But,
showing
yeah.
on screen here?
I'd have to open it. 1 second.
So this is
I
a
will open it.
picture
I
at
just don't know how to-
sea in the fog, which is kind of a scaled down version of the atmosphere, a longer observation.
Oh yeah, no, I can. What it looks like is mountains in the background, so I wouldn't call that a meeting of the sky and the water. So I wouldn't call that a crisp horizon.
Okay. Well, I'd like to see
Not
what
that-
you think
that
a crisp
particular
horizon.
Yeah, but the horizon could be the mountain itself.
Can I have a go, Brandon?
Yeah. So Professor Phil's GIF, Lair Bear's picture with the Chicago skyline. Those are pretty crisp horizon because you can see water, then you can see sky. Those are really good examples.
Here's one other point about you saying that it would kind of fade out. There wouldn't be a clear line, a clear demarcation from the sky and the sea. If you look at these fog pictures, you can clearly see what I'm assuming you would call a horizon, which is the water, and then above it the fog, right? Or the sky. And you can clearly see that line there. And the reason this happens is because the physical space is being condensed into smaller and smaller visual space as you near the conjunction of the further away from you, essentially. So that precipitation in the air, or any molecule in the air, is going to get condensed, and it's going to come to a point where it's just too thick to see through it.
Right, and it wouldn't, and it would remove that horizon. That's what I'm saying.
No.
So on
you
a
look
flat
at this
Earth,
picture right here. You see a horizon.
Opening it again. Oh yeah, You probably could call that a horizon, but I wouldn't call that crisp or clear. I would just say that might be a horizon, or the fog is too thick to see past that point.
That's what
But
we're talking
I don't
about.
think it's a good example for anything.
That's what we're talking about, though. We're talking about the atmosphere being too thick to see through it, and that's the case here. So it doesn't just kind of fade out. There is a point where you see a junction between the two. You can see that, right? There is a clear demarcation between up here and down here.
I understand what you're saying. Where if we have super thick atmosphere, such as when we have fog, we're going to have some type of blur. And in this specific example, the atmosphere is not thick enough to cover up where the horizon probably is.
No,
I understand what you're saying.
that's
What
not what I'm
saying is, what you're presenting a picture of a horizon, what we would call horizon, and fog, and it's kind of obscuring it, sort of, and that's essentially what you're saying.
My point is we have a medium here, which is the fog, and on a relatively short scale, we can see a demarcation, and that's just due to the condensation being condensed into smaller and smaller visual space. You understand? So it does give a line that one could call a horizon. The same thing would happen with the atmosphere over long distances.
This fog isn't creating or giving you the horizon. The horizon is there. There happens to be fog, making it a bit blurry. Such as when you look on the right side of your picture that you're presenting, that crisp,
Brandon,
clear
can I back you up?
horizon. That crisp, clear horizon doesn't really exist on that right side because the atmosphere is too thick. What I'm saying is, in the example that I'm trying to give, is that long distance on a flat Earth in ideal conditions, fuck rain, fuck snow, fuck fog, in ideal conditions, would never give you a crisp horizon. It would just give you land forever until it fades out due to all the atmosphere. That's what I'm
pushing back on. But go ahead, Gleam.
Disagree. If you look at my screen, I don't know whether you can see that, but I can zoom right in, and you can see a crisp horizon, absolutely crisp horizon, and I can even put a high pass filter on it and show you that there's a clear contrast change between the waves and the sky. However, that is literal fog. Fog will create a horizon. This is just foreground waves breaching or being the highest they can be before anything's blocking the background out. It's not necessarily that is the curve of the Earth, because obviously the curve of the Earth would not be there and this be this big.
Do you have an original for that picture?
If you literally search up the words cruise ship in fog, it comes up straight away. It's an article, an Australian article or something. But I can quickly,
awesome. Yeah, that's a great example of that.
But yeah, I don't know whether you know, Jewel, but I'll just pop this in the general chat. But above a few kilometers, above a couple of miles, you can never see a clear horizon at all.
It's dangerous to say never, right? Because it's just
no. This was tested. This is due to science, and that's why I'm posting it. It's Bowen and Fraser.
I know. And are you going to stand behind long distance? Let's say 10 plus miles.
Yes.
Are you going to stand behind that 10 plus miles? We won't get it.
If you're a few kilometers in the air, this is it was with altitude. Okay, so it's not to do with horizon at small distances. It's to do with at what height do you need to get before you will not see a clear-cut hard horizon, is what they call it.
Yeah, so I would disagree with that as well, for obvious reasons.
But I mean, why would you disagree with science?
No. I'm not disagreeing with science. I'm disagreeing with you and your assertion. I understand that you probably got this information from somewhere else. I'd be interested in reading that, but you're presenting it. I'm disagreeing with you.
It's in the general. It's
okay,
in the general.
I'll open it up. I'll read it.
It's a NASA. It's in the a published journal. It's read away, my friend. I just obviously put the abstract there. I didn't quote anything specific. But yeah, pretend that it's me again. Okay.
Yeah. So, I mean, if anybody has an example that they think shows some kind of clear, crisp horizon, we'd be interested in seeing that. Because I can't remember a good example, to be honest.
Maybe Chaiki, since it was his claim.
Somebody, yeah.
Yeah, anybody. I look at I look at horizons as many times as I can, especially over water. I love it. It's beautiful, right? I've never seen one. I was totally shocked on the days that it looked so clear and crisp, and then you zoom out or zoom in, however you want to say it, and it's just so distorted. It's so different, from that 3 or 4 or 5 mile horizon of yours. 1 mile further, it's just totally crap. You can't even see an oil rig that is there. It's not fog, like he said. It's thickness of the air, yeah, but distance is the key, right? That thickness can be closer to the viewer or further off or at a different layer or only at the surface level. And then there's a clear layer, and then it's distorted up above. It can be mirroring, it can be miraging, it can be, come on. Make a list.
Yeah, you start adding them together too, because
Yeah.
it says only one phenomena is going to take place at one time.
Yeah. Take a fraction of one and half of another and the full effect of another, and voila, you got yourself a pretty good little magic trick. It's called an optical illusion. It's also defined as a mirage. Optical illusions caused by atmospheric conditions. Pretty simple definition.
If you want to see a great channel that has a ton of observations, check out The Plain Truth. For anybody who's not familiar with that channel, probably mostly for the audience, but he's got tons of stuff out there. And there's another one. I can't remember his name. He does the videos where he's got 2 cameras on a lake and he shows one lower,
Life
one
is short.
higher. Say that again, Gleam.
Life is short.
Life is Short does that too, and then there's one.
No, you're talking about Heath Carmody. Heath Carmody.
Yeah, Heath
And
Carmody.
the Plain
Heath Carmody
Truth,
does a
the Plain
great job
Truth
too.
is another good one. Ether Band channel. I think you read that. He's doing some. So yeah, Heath Carmody and the Plain Truth are also good channels.
And Sky Free as a third.
Shout out to Sky Free, man. Hell yeah.
Absolutely. There's just so much.
We've
stuff
proven that even Jim Penn has seen it with his own eyes and denied it with his own mouth. That we showed that just with a little change in temperature, without moving any camera or anything, you could see a light disappear right in front of the camera. The light's on, you open the door, change the temperature a little bit, bam, a light with perfect line of sight that nobody moved just disappears. It's just reality. It's a lot of phenomenon going off in the distance. Nobody will ever fully understand it, in my opinion. But it is a very interesting topic. I think a lot of us here, look into it pretty deep. And the more you look into it, the more, the harder it is to explain, in my opinion.
Yeah, shout out Pebble on the Pond. He did some observations that were pretty interesting too. With the one that
Ranty Flat Earth.
The light. Anyway, so yeah, I don't think it's a reasonable assumption, based on the conversation we just had, to say that on a flat plane, we would, the horizon would essentially never deviate from eye level, the center of your vision, no matter how high you got. So that was the only point I wanted to make. I just wanted to understand where people stood on that assumption, because it is one of the key things that the globe relies on for its mathematics. All right, well, open panel, guys. If anybody has a topic, feel free to bring it up. Otherwise, I got stuff.
Yeah, I will say on that same topic, you also have a differential in the wave heights, where even though you may have small, tiny waves right near your feet, it could be 7 or 8 if you're looking over large bodies of water. could be 7 or 8 meters out in the middle of the sea. And that is going to have an effect of kind of like swelling, and then anything behind it's going to be blocked by that. And
I'll
you can
back
also, yeah, you can also say, yeah, that's the Earth curve, that's the horizon, because that's where that 6-foot wave meets the sky.
I'll back you up on that, Gleam. This weekend, the wind was coming out of the north. So the beachfront to about 5 miles out was slick calm. I'm talking about not a ripple hardly, right? No waves. Now, 10 miles out, there were 6-foot waves, right? There you go. That was this Saturday. My boat took waves over the gunnel, right? But by the beach to about 3, 4, 5 miles, it was calm. So if you're viewing from the beach and you're trying to see something 10 miles out, it's going to be obstructed, especially if you're lower than 6 foot.
Here's that Pete the Great or Pebble in the Pond observation, if anybody needs a reminder of what this was. Pretty cool. I'll just describe it real
Oh
quick.
yeah, yeah, I remember.
He was
now.
in a factory, and I think it was, I'm trying to remember how many feet away. I think it was like 100 feet between the camera and the light, the flashlight that you see down here. The flashlight's sitting on the ground, and he has a garage door behind him. And he's going to open and close the garage door. It's warmer inside than it is outside. There's a huge difference. Inside, I think it was around 68 degrees Fahrenheit. Outside was like 30, if I remember correctly. So he opens and closes that, and just see what happens. It's open. Kind of a small scale look at some of the phenomena that can take place just through the atmosphere. And closes the door. And bam, you cannot see that light anymore. It is completely obstructed by the atmosphere. We know it's there. Can't see it. Pretty cool. Lots of other things happen in mirroring and all kinds of stuff. What I wonder is, let's say at 1,000 miles away, is there a mirroring band where at 1,000 miles, the amount that would be mirrored or concealed behind this atmospheric effect would be hundreds of feet high or thousands of feet high?
There would
I
almost
wonder
have to
about
be.
that. Yeah, so that's pretty cool.
But Brandon, it's like if you do the math, the angular size of a mountain would be like Mount Everest would be starting to become invisible right around 1,000 miles, wouldn't it? I mean, based on angular size and all that, we would got to see that exists in reality, unless you want to call it stars. I don't know. I'm digging a hole.
Yeah, no, I get what you're saying. I haven't done many of those calculations myself, but I'd imagine that at some point, yeah, Mount Everest and everything else is just going to be not visible. NASA finally fixed the Hubble Space Telescope after almost 5 weeks. Troubleshooting a mysterious glitch. Thought this was kind of interesting. They went up there and fixed Hubble, supposedly. Lots of people who think Hubble is actually on a plane, Sophia, and not.
Yeah, that means that Sophia pilot's off vacation, so they fix Hubble. The pilot's back.
Right. They've got some pictures in here that they are telling us are real here. This one right here, I can give you pictures of a dog floating up there with it for $5. Anybody wants that? Also, the Earth looks pretty damn flat to me below the Hubble telescope in this picture. Thought that was kind of cool. And they're talking about how they fixed it back in '93 because it was malfunctioning and all this stuff. I haven't seen any in-depth research about what happened in '93 with Hubble, but that would be interesting to see. I remember that was a huge deal.
Hey, Brandon.
Yeah.
I know you. I just posted it 6:17. If you want to grab it, it's a sun fade out at sea level that I took myself. If tonight or one day you want to talk about it.
No, I'll bring it up right now. I was just kind of filling time there with that. Let's see.
I didn't edit it or nothing, so the wind might be, you might want to turn it down. But at the end of the video, the whole video is nice sunset with boats going in it and out of it and all that. But the end is a sun fade out at sea level. I've never seen one.
Is this the one you posted yesterday, Rucky?
No, this one's been posted for a while.
Oh, okay.
Wow.
Yeah, the one yesterday was just a sunset. Matter of fact, from the same position, same dock, it's just different conditions create different sunsets.
You have a filter on, or?
Hey, Rakia, are red snappers legal yet over there?
Yeah, season. We fished Saturday.
They're illegal over here. They've been illegal. Now all you can catch is a fucking red snapper. They've been illegal for about 10 years, and they made a comeback like you wouldn't believe. I think they're just about to start where you can keep a couple of them, but they're all you catch now that you can't keep them. They're all you catch, man. I've got some monsters, man, some mules.
Just posted Saturday's pic of the guy. He flew in from New Jersey to come fishing. He had a good time.
There's some of the biggest fish I ever caught were out there in the Gulf, but they were off the coast of Florida. But over here in the Atlantic, I caught a mule snapper. They put me on the front of a beach magazine down here, one of the Beach Bull magazines. They put me on the front of it, man, with a big old mule, man. Probably about 38 pounds, I think. Monster.
So you do commercial charter, Rukia?
Commercial what?
You charter fishing?
No.
Okay.
That's just private. People coming to have fun. People like friends and family we know, whatever. I have a guy coming in from Israel and his family this weekend through our church that we're bringing out.
So I'd like to discuss that sun fade out with you, Rakia.
Yeah, has it been posted?
You posted it.
Oh, okay. I didn't know if Brandon was able to bring it up.
Yeah, I'm playing it on the show. And
yeah, go to the 1 minute mark, please, Brandon. Go to the 1 minute mark.
Okay.
Yeah. Could you explain to me what is happening at the 1 minute mark, please, Rakia? I'm just trying to understand the image that we're seeing. Could you explain that?
What are you referring to, Brenda?
At 1 minute mark, explain what it is that we are seeing. Since this is Rakia's image and he posted it, or his video, not image. What is it we are seeing at the 1 minute mark? What are we seeing there?
That's a sun that 6 hours before this was up above you. That's now further away from you as a viewer, and it's lower.
But where is the sun?
What do you mean? It's right there. You don't see it?
No, but I only see half of it. Where's the other half?
The other half is being obstructed by something.
What do you speculate that something might be?
There's buildings over there, trees, atmosphere.
Doesn't look like the buildings are big enough to obstruct that much.
What do you mean? New Orleans is right there.
It
The
doesn't look like
Superdome.
but that doesn't look like, they're big enough to obstruct that much of the sun.
Right.
Where'd the boat go? Where'd the boat go?
The buildings are a lot further than that projection of that light right there.
Yeah, but their angular size is quite small to us in comparison to the angular size of the sun, as seen in the video. So they're not enough to obstruct.
Yeah, it's huge on that horizon. Ain't it, Brendan? Real big on that horizon. Why does that happen?
I'm asking, where is the lower half of the sun? You're saying
You're asking like
buildings.
you're an expert on the sun, though. That's if we're going to be experts on the sun. Let's answer all the questions, Brenda.
I'm not. I'm an expert on seeing
You don't
things.
even know where the sun's at, Brenda.
I'm asking, where is the lower half of the sun? You're saying that it's obstructed by the buildings, but the buildings are not big enough to obstruct it. They're not big enough.
You mean the light
What do
you're
you
seeing
mean
in
they're
the
not
air?
big enough?
You can see that they are only a very tiny percentage of the entire disk of the sun there.
Brenda,
They're not.
name me one object in reality that going off in the distance doesn't get lower and lower. Name me one thing ever in the history of humanity that doesn't get lower as it goes off the distance.
The sun, according to flat earthers, the sun.
Everything we see that goes off in the distance gets lower. There's
So,
no
Brian-
avoiding it. There never has been. There never will be.
So Brian,
Thank you.
I'm just asking Rakia to
The
explain to me
object
what
doesn't get lower. That's the way it appears.
I'm just asking Rakia to explain to me his video and where the lower half of the sun is. He's saying that the buildings are obstructing it, but they are
No,
obviously
you heard only one part of my answer. Why are you just saying the buildings? Because you think that
What else?
that makes
What
it look
What else?
like not possible. The atmosphere. It's being distorted, right? It's being obstructed.
Could be Mount Everest, Brenda.
Atmosphere
Could be Mount
doesn't
Everest for
obstruct
blocking
things. Atmosphere transmits light. It doesn't obstruct light.
Yeah, cool story, Brenda. Now look at the video where it stopped right now. Is the bottom half being obstructed by something?
No, it's being refracted.
So
not
now it's
obstruction.
refraction?
Right. Refraction is not obstruction.
Okay. So you don't agree that the atmosphere at that angle could obstruct something in the distance?
Atmosphere refracts images.
We heard you, Brenda. Then I asked you a question. Can objects be obstructed
No.
by the atmosphere at that angle?
No.
Okay.
They're refracted.
Refracted,
They're not
refraction.
obstructed.
Distorted?
Why can I
Yes.
look at the sun on
So
the horizon,
question
Brenda?
So the question you have yet to answer is, where is the lower half of that sun at the 1 minute mark?
No, I answered. You just don't like
You
the
did-
answer.
Well, your answer is insufficient.
Where'd the bottom of the sun go?
It's because the buildings are not big enough.
Okay, here we go, Brenda. Let me tell you the truth. I've been lying the whole time.
This is why I
Back
asked her at
up-
the beginning. Asked her at the very beginning of this show, Rocky.
When
I
you
asked
see,
her,
hang on, let me answer. When you see half the sun, Brenda, you're actually on a spinning ball. You're spinning about 800 to 1,000 miles away from the sun. And as half of it's being shown, it's actually already set, but that half is being refracted up to your vision to see it perfectly. But you never saw the part that got refracted. It's just at that point it's being refracted up in our model. And I'm sorry I've lied to you all these years about being a flat earther, and it may be distorted or refracted down or looming up or sinking, and the atmosphere is distorting things, the light getting to your eye at that angle. That's all been a lie. The truth is you're spinning away from that object at 1,000 miles an hour, and it's already set. It's already gone over the curve of the Earth, but it's being refracted up so you still see it. Are you happy now?
So whether or not it's been actually refracted
You know
up
that's your model, right?
Oh,
so whether or not it's been refracted up is irrelevant to my question.
Like you didn't even talk. Like you didn't even ask a
Right,
question.
because you shifted your
Like talking to a fucking mule.
No,
Right,
I made the
I am
model that
stubborn.
you live by sound ridiculous.
You don't have a model. You don't have a model.
No, I said your model.
You don't understand
have a
our
model.
You don't
That's
understand
all you
the
have.
model.
I just verbatim. I just said it.
So where is
When
the
we
lower
see
half
half
of the
the
sun?
sun, yeah, it's refracted up. That sun has already
That's
set.
not
Brenda.
how it works.
And we're oh yeah, in your model it does.
No, it isn't.
Oh yes, ma'am.
No, it doesn't refract selective parts of objects.
What are you talking about? In your model, that sun has already set.
Yes, and the entire
it's being
sun.
refracted up.
It doesn't selectively work on just half of the sun.
Well, at that point, it's already set, and the only reason you can see the half that's sticking up is because it's being refracted up in your model, Brenda.
But refraction
as you're spinning 1,000 miles away from it.
Refraction isn't selective on the sun. It doesn't just.
More questions.
I have a phone call. I have to go.
See you later, Brenda.
Of course you do. You won't answer why we can look at the sun with our bare eyes when it's down in the thicker part of the atmosphere.
Keep playing until it fades out, since you tried to obfuscate away from the fade out, which is the whole point of showing the video.
It's like talking to a donkey, dude. It's unbelievable. Where's
I'm
the
on
bottom
a-
of the boat go?
I'm on a pier.
No, but a donkey will turn left or right when you tell it.
There
Even
it
if you
goes.
slap it, it'll go back home from where you're picking the grapes on its own.
So Dave Weiss has this with his drone, and I've never seen it any other way. I've only seen it from high mountains and drones. I've never seen it from sea level. And this was the first time I've captured it.
Really cool.
Yeah, you get it a lot with a drone, but you need a clear day and you need altitude. So clouds over that stretch, clouds that stay over that stretch is not very common, but it happens.
Now, this was a cooler day in early July, if you can believe
So
that, in
I'm back.
Louisiana.
I'm back.
Yeah, but you don't automatically get to come back in the conversation and dominate, Brenda. We've already kind of moved on.
Yeah, they think that
I'm
the
just telling you, I'm back.
the clouds that move off in the distance, the clouds that are just sitting on the water and starting to fade, kind of tie into the water, they act like everything we see doesn't drop off and combine with the horizon in the distance. Everything we see and everything we've ever seen drops off in the distance. Okay,
That's
why
called
can we look at the
perspective.
sun? Yeah, exactly. Why can we look at the sun with if it's just a couple miles of atmosphere? You say that the angle doesn't have shit to do with it. The atmosphere doesn't. Why can't I look at the sun with my bare eyes when it's rising but when it starts to get overhead, like about 20 degrees, it's too bright for me to look at. You care to explain that?
Because it's traveling through more atmosphere. That's why. Which wouldn't be the case. Which wouldn't be the case on a flat Earth.
So what's that got to do
So
with
it's more atmosphere. Thank you.
Yes.
Brenda just answered. When it's lower, it's going through more atmosphere. A lot of more
That's why it's
miles
red.
of
And that's
thicker
why it's red.
atmosphere.
the farther
That
away? it
doesn't
goes,
explain.
the more
But
atmosphere it
perspective.
No, thank you, Brenda.
Perspective does not explain obstruction.
Brenda, explain that fade out right there.
Brenda, the sun
It's
doesn't
gone over the horizon. It's gone over the curve.
It didn't
Over
go
the curve.
over anything. You see
Yeah,
the
it did.
light disappear.
The tracks don't touch.
Are you
Brenda.
blind? It fades out,
Yeah,
Brenda.
that's what happens when something is obstructed. The light.
Obstructed by what? It
exposing
fades out.
yourself
The
because
Earth.
you're not acknowledging what's clearly obvious. In
What
this
am I?
video.
What am I not acknowledging?
You can still
Here.
have your ball, Brenda.
Right here, there is. You see this gap forming underneath the sun here?
Yeah.
See that? You see how it's the same
about
color as this up here? This is the sky, right?
Yeah, this is caused by
Sky
refraction.
too, right?
Yeah, it's caused by refraction.
Okay, so why does it
everything
fade
you
out?
see in this picture
refraction
related
is
to the
hiding
sun,
something.
the reason it looks like
Refraction
it's
is
going
obscure.
behind something is because of refraction, Brenda.
No,
The sun,
the
you think the
refraction.
sun's that big, Brenda? Brenda,
The refraction.
is the sun that big?
The refraction is occurring at the same
Brenda.
time it's being obstructed.
Is the
Is it
sun
more
that big
likely?
when it's close?
Sorry.
They are separate. They are separate phenomenon occurring at the same time.
Brenda, is the sun that big when it's close above your head?
The sun never changes in angular size.
It changes in
So
appearance.
not even a sun dog, Brenda? When we see a little sun and two tiny suns, does it change then, Brenda?
Those are due to optical effects. Those are not.
Does it change size, Brenda? Does
The
it even
sun-
change number
The
of suns?
The sun's angular size
Yeah,
does
this
not.
is my point. Hold on, Brenda.
So
Rewind
he
that little
asked me a
bit.
question.
Rewind that a couple seconds.
You should respect
Rewind
your
that.
other flat earthers
Rewind
and
the
not talk
video.
over them. Dem.
Rewind the video. Stop talking. What are you talking
You should
for?
respect your flat earthers and not talk over them, Dem.
You should
Brenda,
shut up.
take a break.
Rewind. Now look how big that is. Brenda, is that how big the sun is over your head? Brenda.
This is zoomed in. What are you talking about?
Brenda, at the horizon, are you telling me that matches the sun over your head?
Measurements of the angular size of the sun do not change significantly over the course of the day. No, they don't.
Yes, they
Over
do.
the
Sun
course of the
dogs,
day, Sundog is
sun
not the
dogs, Brenda.
sun.
You get a medium-sized sun through a filter and two little tiny white balls. So don't lie.
That's not
You don't even
the
get the
sun.
same number of suns. It's an apparent aberration.
So
whatever the fuck
angular
it is.
size of the sun, the angular size of the sun does not significantly change during the day.
Look how big that is. Look how big that sun is, Brenda. Look how big that is.
Zoom. Do you know what the zoom is on a camera?
Hello, Brandon.
Do you know what zoom is?
Hey, sounds
To see the sun big as fuck,
What's
Brenda,
up, man?
you need no zoom. Just use your eyes, Brenda. Your sunsets will look like that, Brenda.
So I wanted to say, Brenda, that perspective does actually make things disappear bottom up. It's just that you guys don't understand. Well, yeah, interrupt me in my middle of my sentence. You guys don't actually understand what perspective does when you see objects in the distance.
Would you
Makes
explain it
look
to me?
Smaller. Yeah.
Would you explain it to me then, please?
Yeah, it's really simple, right?
Can you demonstrate? That's what I'd like to say. And
Your fellow flat earthers are not respecting you.
That's left lane, Brenda. You moron.
Yeah, I'm not. I'm just saying. Just saying. Thank you, Brenda. I would go right along with you on that. If you could demonstrate it and show it to me and how that
you
works.
can demonstrate an angle and show me an angle, countryman.
Right. So somebody else had a question out there.
Angle tilt on that boat, left to right. Look at the sun. Look at that no tilt on your globe. No tilt. How does that exist? How can you have no tilt on a globe? How? Where?
So the question is, that's not the question.
Can you see the sun's picture? Now put that boat on the sun going around the sun and watch what it'll do. Tilt, sun.
Yeah, that boat's less than about a mile away. Brandon, I'd like to finalize by saying I also have a video of a boat doing the same thing about 4 miles away from me as a viewer. It just fades out like this. It starts getting distorted just like the sun did here, bottom up. And then you can still see the waves splashing off the side of it when it
fading
blinks out. Hang on, Brenda, I'm almost done. As the boat fades out into the sky, you can still see the waves splashing off to the right. I can post that video too, but it's basically
I've seen that video.
the same
It's a good
thing.
one, man.
As the
That's a good
objects
one,
go
Raphael.
far
And if we
away
go
from you, they
around
get
the sun,
smaller and then they start to fade out in some conditions.
Right. So this is not fading out. It's going below the curvature of the Earth. It's not
She doesn't
fading
even
out.
acknowledge what she sees with her own eyes.
Brenda, come on now. We
It's
see it
unbelievable.
getting smaller and
It's
smaller
literally,
here. We see the
it's
sky
literally
underneath it. We see
going
the sky
below the
above it.
horizon.
And here it goes. It's going to watch,
This is Antarctica
Brenda.
all
There it
over
goes. It's
again.
fading out.
Going down. It's going down.
Brandon, at this point,
No, it's not. It's disappearing into itself. It's like it's shrinking and shrinking and shrinking, and then it fades out
Because
again.
Rakia decided he's going to change the setting. He's going to move the camera, change zoom, change exposure just when the sun sets.
It doesn't go down off of the distance. That's what I asked earlier. What does it go down off of the distance?
Nothing will change if he didn't change all that.
Sorry. The light pole
I
does
say
not go
something,
down inside
Dimok.
the earth, Chike.
Dimok, no one.
At this point, Chike, at this point, guys, I mean, you have it in your front of your eyes. You're seeing it, and you're denying it. I mean, what else can we do, right?
Look, you see that
There's nothing else we can do.
out.
If you say that
zooms out.
thing is going down,
You see that it zooms out. That's clear.
Where's the boat going?
You can ask
How come the
Rakia.
boat's
He can
not
deny
down,
it
but
if he
the sun is?
wants.
Yeah, he's
How is the
basically
boat down?
lying with the camera.
Your
Why are you
eyeballs
guys?
see the same
Why are you guys
sun.
accusing Rakia of faking this video or whatever you're accusing?
Because he's
What exactly is
altering,
the
he's
accusation?
altering exposure.
Brenda's saying that she's never saw a sunset before.
Hold on, let's
He's
hear
altering
their
the
answer.
setting.
They're
Brenda,
just
that's rich.
bullshitting and
You
throwing
shouldn't
shit
accuse
against
people of
the
that.
wall. So why are you saying that? Brenda,
Look,
Chikey,
change
you made an
the settings of the
accusation. What do you have
camera.
to back it up? Because it looks like he holds the same position to me the whole time we see the sun fade away.
Yes, he zooms out.
Yeah,
He's
can
recording
you?
the same thing you would see with your.
How does that affect what we see right here?
Way
Look,
before.
this is see
You
this
can
white
zoom
area
in and
right
out all
here.
you want. It still fades out.
See this lighter area
So
right? Yeah,
the-
this doesn't even matter.
No,
This
it
is a red
changes
herring. You
if
see this
your
lighter area? It
exposure,
stays
exposure
the same
settings.
the whole time. The boat stays in the same relative position, and then we see the fucking sun fade out. And you're trying to make excuses. Why are you trying to make excuses? I find that interesting.
Zooming out.
Huh?
He's zooming out.
No, he's not.
Yeah, he literally is.
And what would that matter even if he was zooming out? Why would that matter? Why would that matter?
Why you?
I'll tell you right now, I'm zooming in and out the whole time I'm taking this video,
Right,
and it matters not. It matters not. This is a sun fade out
I know.
at sea
So, Brandon,
level. I don't care what you say.
The reason why it matters is because we're discussing the angular size, whether it be.
No, we're discussing sun fade out.
Yeah, we're not talking about the angular size.
We're not talking about angular size.
Look how big those birds were. I could get to the end of what I'm saying, right? And then you have a clearer picture of what I'm presenting.
Zooming in and out won't change what's happening to the sun. It's only changing what you can see of what's happening. So that sun is still fading out, whether you're zoomed in on it or not.
This doesn't even take away the ball or prove flat Earth. This just shows a sun fade out at sea level, and they're denying it because their ball religion is so
These
strong.
people need to deny reality, right? That's what they need to do. They need to deny reality of their own eyes, right?
There's no denial. There's no denial. It's literally what happens is it goes over the curve.
No, literally what happens most of the time is that it goes down. On this day, because of the conditions, it faded out.
You're zooming in and then pretending.
You can zoom in and out and it still goes down 90% of the time.
Away.
On this day, I'm zooming in and out and it fades out, Brenda.
That's
Why you call me a liar, you're a liar.
Yes, you are a liar. You
Yeah,
zoom
there you go.
in. You
Oh,
zoom
you are.
in to give it the
I
appearance.
did
of
never say
fading.
I
You
didn't.
zoom in. You zoom in order to lie with the camera.
Brenda,
Brenda, you are a
Brenda,
pathetic
zooming in
human
on
being.
something can't make
Pathetic.
something
Listen how
occur.
delusional
That thing
this
is
person is.
occurring. It's like if you say somebody at the end of a kilometre hallway is getting undressed. You can't see them, but you zoom in on it, and all of a sudden you can see them. Oh, they started getting undressed when I zoomed in on them. Well, no.
So Brenda, all the sunsets I've posted of the sun just going down and I'm zooming in and out, is that creating an effect of a sun going down?
Sun.
No, listen.
You're a moron.
Your exposure is changed.
Chikey,
Your
be
exposure.
quiet
How
about
does
that.
the
You're
sun-
making
wait,
yourself look ridiculous.
you
Let
see-
Brenda
we
do
see
it.
the sun, listen, we see the
Brenda
sun
is doing
going
it
down.
for you, Chikey. You don't have to make yourself look ridiculous, sir.
Look, we saw the sun behind the horizon, then it moved up.
Okay, awesome. I saw a sun fade out. I don't know what you saw. About 1,000 times from the same position on the pier at my marina, I've seen sunsets where the top of the sun appears to go below the horizon. Okay, that's what to me is a sunset.
Yeah, once in your
On
life,
this day,
right?
as you cut me off, I saw the sun at sea level from the same position with the same camera, basically, fade out. And I think it's
Brenda,
due
did
to
you
the
hear that?
conditions of the day.
Rakia, next
Did you
time
hear
go,
how an honest
try.
man talked to you, Brenda,
Right.
just now?
I think it's because of the conditions of the day.
Rakia, next time you do there, try manual exposure, not auto exposure, manual exposure.
That's the most ridiculous argument I've ever heard.
Try.
This has nothing to do with focal length,
Oh, it
exposure, or
does.
anything. No, it doesn't. You saw it with your naked eye, Chikey.
It's as easy as this.
Yeah, people were there watching it. They saw it.
I must be not coming in.
Are you
I
buying this
must
too,
not be coming in
Biodual,
on
or are
mine.
you going along with this red herring here?
I don't know. If I could get to the end of my explanation, it'd be cool, right? Then we could find out. So when I'm watching this video now, I couldn't chime in before because I didn't see the video. I just heard everyone arguing. I'm currently watching it, and I've watched it a few times. There is zooming out occurring. I don't think it changes drastically what the observation is. What I see is refraction at the where at the horizon. Essentially, what you can see is at the ends of the sun, the left and right side, you see this curve up. We know refraction is taking place. I wouldn't call it extreme.
No one's denying that.
I could get to the end of my fucking statement, Rakia. So we can see this curve up. We know that things are happening at the horizon. I see a sun lowering in the sky, and that refraction is just taking place at that point the entire time. Now, I understand what you're saying with the fade out, but what we see from the beginning, if you can go back to where we see like what we can see of the sun when it's that half sun, when we go to that, we can see how crisp it is. We can see how we can see the size of it. We can measure from left to right.
You're rambling.
Shut the fuck up, Rakia.
Well, you're rambling.
What we can see here is left to right. We can see a giant ass sun. In the globe model, it's lowering. If it's lowering beyond the horizon, it's going to be less of that circle that we can see. And we can see it smushing left and right because it's going up, it's going down, of course.
Yes.
If we
and
had
on
a
most
fade out,
days.
if we had a fade out, it would be a different effect.
Jesus.
It would be fading from all directions. This is just fading left and right, and it's moving down. So we're seeing less of that arc. That's all we're seeing right there.
You would agree that normally we see this ball like this, and it goes half, and it goes quarter, and then it disappears. It's always clear. It's a big ball. It starts disappearing bottom up, and it goes down until you can't see the top anymore. Right? That's a normal sunset, right? On most days, most conditions, that's what you see, correct?
Most days here and sunrise, there are clouds in the way.
And on this day, the sun didn't do that for some reason. You're saying refraction.
Right, because
you're saying refraction. Congratulations. Yeah, refraction is making it fade out.
Of course.
Yeah.
You can even see when it finally does go down below, you can see the effects of the clouds in the atmosphere waving at the very top, right before it does disappear.
Yeah, it's getting further away.
If it's getting further away, we can measure the angular size, Rakia. Let's not go there. But
How
when
can you
see
measure the angular size of something that's being refracted, sir?
Oh my fucking god, man! You can.
Yeah,
measure
oh
the
my
angular
god!
size.
You want to scream refraction? You want to say how it's being distorted? It's being curved up, and then you want to measure it.
Imagine.
You know how moronic that sounds. Imagine someone saying they want to measure something when they just said that same object was being so distorted that it's curving up and that it's fading out.
Oh,
bottom up.
That's right.
Yeah, keep measuring something that's refracted.
Because you're fucking worried about the explanation.
Measure that refracted light in the sky, sir, and then come to me and try and be honest.
Rakia,
Can't have a fucking adult discussion, man. So yeah, you measure.
You mean like being called a liar and being called stupid, basically, by you saying those things?
Rakia, you can measure the angular size of fucking anything in any fucking condition, but we know that it won't be a reliable measurement if there's a high amount of refraction or fuckery going on.
Then why are you mentioning the angular size on this picture? On this video?
I don't know why you ask me questions when I'm trying
I'm asking you why you mentioned angular size on this video when you just said it was refracted to hell and back.
Do you remember not 30 seconds ago me trying to explain it, but you constantly interrupted? Do you remember that?
No, I remember you rambling on for like a minute and a half about everything, including how refracted the sun was, and then at the very end say it's not changing angular size.
I said when you brought up angular size, I said we could go down that road.
I didn't bring up angular size.
I still can't get to the end. So
I didn't bring up. Don't lie. I did not bring up angular size.
Bio, you're the one who brought out angular size.
He's not the one.
You brought out
problem. He's not the one causing problems. So shut up.
Yeah, he's lying,
awesome. I still can't get to
Hold
the
on.
end of it.
Go ahead, Bio. Go ahead.
I suspect in the next 10, 15 seconds, I'm going to be asked a question of something that I've already tried to explain. That's my prediction. Let's see if it holds true.
Who cares?
Okay,
this is a sun fade out from sea level.
I've got a question for him. In your model, is that the actual position of the sun, or is that the apparent position of the sun?
In all technicalities, it is the apparent position offset by about 8 minutes.
So even in your model, that we're not seeing the sun where it actually is, correct?
In real time, ignoring all laws of physics, we are
no.
Accounting for all of that. No,
Jesus, song and dance.
I don't know, because I have to be pedantic, and you know I have to be.
minutes.
In all,
Go ahead.
in all laws of physics and all things that we know about reality, the apparent position of the sun that we see it at the horizon right there is 8 minutes behind where it actually is in physical reality.
So in your
even
model,
your
it's a
model,
projection.
The sun is not where it appears to be. Why do you think it would be any different on another model?
Well, because the distance would be different. So the reason why it's 8 minutes off is because it's 93 million miles away, give or take. Now, if we use a flat Earth, Earth
Wouldn't the
model,
Earth have
the
been in a
minimum,
different position
the
and not
minimum,
show exactly?
Would you shut the fuck up, Paige?
I mean, I'm trying to. I understand what you're saying. In a different model,
Go to
if
hell,
that model
Brenda.
includes,
You don't even have a model to show us.
if that model includes a sun that's 93 million miles, yes, it will have that
It
same
will,
delay.
Paige.
If your model shows
You haven't
if your
Yeah,
model
I know.
shows a 3,000 mile away sun, it won't have that delay. The distance is why there's a delay.
What does the distance have to do with delay? Is that what you're saying? That the
The
8 minutes is why
the speed of
it's
light.
not in its correct
Correct.
position? The 8 minutes
The
that
speed
the
of
light
light.
takes from
Correct.
to get
So
from the sun to the
Yeah,
earth.
what he's saying is our model has to
Right.
conform to his explanation, to his model's
no, it
explanation.
doesn't. No.
Well,
This
if you
is
go by
because
that biodual, then
um,
that we could apply that to anything, any celestial observation, right?
but it does,
So-
but that delay doesn't change the argument here. That delay has nothing. That delay has nothing to do with this observation. So it
That's
is.
nothing
This
with
is
the
by
globe.
definition. This is by definition a red herring because that has nothing to do with this observation.
That's nothing to do with the globe that doesn't exist or a distance you can't prove.
Isn't the light
Yeah,
said to be
Brandon, that's why-
refracting through the atmosphere, and that's the only reason that you can see it?
This observation would
In your
occur
model.
if the sun were closer. This observation could occur the same way. The fact
In
that there is
your
a delay
model.
or the amount of the delay doesn't change this observation.
What makes the sun says refraction? I have it mapped. I almost have my my flat Earth refraction model down to a T now, man. I'm about ready to present it with confidence. It's just refraction. That's what makes shit sink and rise in the distance. Look, some things sink, some days it sinks. Distant observations, they move around,
Hold
man.
on,
If you look
Brian.
at Skunk Bay, yep, go ahead.
I'm sorry, but I don't want to get away from this point, and then I'll let you have the floor. So this is what I'm referring to, Biodual, do you know that you can actually see the sun a few minutes before it rises and a few minutes after it sets? This is because of refraction. And if you see this little diagram, it's the same one you guys rely on for the selenium eclipses. The true position is actually below the horizon, but the perceived position is above the horizon due to refraction, not the distance, the time it takes
I'd like
the
to
light
add
to
on.
travel the distance from the sun to the earth. So I don't know what you're talking about.
I know that plays a part in it. It'll take me 30 seconds to show the 8 minute delay due to the distance. I know that that information is available.
Yeah, but that delay is
Brandon.
is regardless of. We're talking about the refractive effect. We're not talking about the time the light takes to get from the sun to the earth. We're talking about the refractive effect.
And I agree with you. Didn't I just say?
Good try, though, bud. Good try.
Hold on. Didn't I just say?
May I say
15
something?
seconds? No, because I'm trying to fucking talk here. God damn, man. So didn't I just say 15, 20?
Don't curse.
Fuck you. Fuck you.
All right,
Didn't I
come on,
just say?
let's
All right,
15,
that's
20?
fine.
You got to give them a
Don't
chance.
be a
to explain.
blasphemy.
Didn't I just say 15, 20 seconds ago that the distance to the sun has no bearing on this observation? Didn't I say that?
But I was asking you about your model, and that's when you brung up the 8 minutes. That's how we got there.
Right.
And
Yeah, you
Because
said in our
that is-
model the sun ain't 93 million miles away. That's what you said, bud.
Because you brought up the distance to the sun. I don't give a shit about this observation and the distance to the sun. It has no bearing on.
Okay, let me go back now that we've got this new information here, that this little refraction thing that causes the perceived position and the true position to be different. Let's go back to my original question. Biodual, in your model, where we see the sun, is that its perceived position or its true position? Do we see the sun in its true position at sunset?
Perceived position in all technicalities.
Okay, so it's not actually where we see it. So why would that be any different in another model than it is in your model? Why do we have to come up with some elaborate excuse when all you do is claim light bends?
As I said, this specific observation would still be seen the same way on a different model and different values for the distance to the sun. All of those things mean jack shit to this observation.
The atmosphere doesn't have anything to do with the distance to the sun. This is refraction caused by the atmosphere of Earth. That's what's causing the difference between the perceived position and the true position. So we don't need 93 million miles into the equation. We need really the thickness of the thick atmosphere. We're talking 50 miles. And the atmosphere would be the same depth or distance roughly on each model.
Being cut off every time?
Because I agree to every specific point that he made.
And the consistency of the atmosphere, the thickness, is not really in contention. So that's the same on both models, right?
Right, I agree. And you're the one who brought up a different model. And the way that these models differ is the distance to the sun, which means jack shit to this observation.
Okay, all right.
As I've been saying the whole time.
In relation to this observation, maybe I misunderstood.
Right. I don't care about the distance. I don't care about the models. Just the observation.
Okay, so my answer to the question of why does the sun look like it is going behind the horizon is due to refraction. You're not seeing the sun in its true position. You're seeing it in its perceived position, not to mention other factors.
Right. And my argument is that the Earth is rotating and the sun appears to be going down. And it seems like your argument is that the sun is just moving away, getting through thicker atmosphere, for a lack of a better word, dissolving the sun and what we see, right?
No, it's doing that type of thing here. So it's getting to the point where we wouldn't see it due to the angle or angular size or something. And because of refraction, it is causing that image to appear to go behind the horizon. That's what I think is happening. Really, it's going
even on a sphere, why wouldn't it disappear?
Whatever.
Right. And if it were the atmosphere, I think it would be logically sound to say the atmosphere would affect the entire thing, not just the edges. There's no reason that if the atmosphere is causing it because it's thick or moving away, so we're seeing through more, the same effect that we see at the edges should exist within the sun. It shouldn't.
The atmosphere is more dense at the surface.
Right, I understand that.
That's why it disappears bottom up at the surface. When the object reaches the surface, it starts getting obstructed. So you don't get that information back to the viewer. It starts to get obstructed. It starts to disappear. You lose that information due to the atmosphere. It would happen on a sphere too.
It would happen to the entire thing, not just the edges. That's what I'm saying.
No, we say the bottom. Jesus.
Go ahead, Ricky. Sorry.
No, I wasn't saying Jesus to you. I was saying Jesus to him, saying the same thing over and over again after I just gave the explanation of why the top, which is further away from the surface, is not being distorted, but the bottom is because it's closer to the surface. And your angle is different, and the surface has more atmosphere you're looking through. It's more dense.
Just on... Go ahead.
May I ask you a question about the 8 minutes?
In a second, because I want to continue with Rakia over there. But I understand. Rakia, as far as possibilities go, if we had no idea, could an Earth rotation with an atmosphere also cause this observation? Could it? Not is it. Could it cause this?
The answer is yes.
Yes, absolutely.
Okay,
that's what I just said. I just stated it. That on a sphere, the same thing would happen. Not because of the Earth curve, the physical blockage, but because it's getting to that angle where the atmosphere is too thick for the viewer.
That'll be a big part of it, of course, and I agree. That's why I'm saying we can acknowledge what would work on both models, and we have to figure out how to differentiate what would work on one and not the other.
We have to measure the shape.
Right, we can measure it.
If we agree that this can happen on both models, then the only way to measure to really find out if you're on a flat surface or a sphere would be to measure, not to observe, not to try and figure out. So you're agreeing that things can be obstructed bottom up by the atmosphere, correct?
In special conditions, yes, of course it's possible. Yeah.
Thank you.
Right. So when we measure it, we find that the size of the sun doesn't change. So
yeah, measuring that refracted object. You want to go back to that? You just agreed that it's heavily refracted by the atmosphere, and then you want to measure it.
This specific example, right? But this isn't ideal conditions, right? You know that.
So can I ask
it's always in the atmosphere.
Yeah,
it's always being refracted.
To answer Brandon's question about what the difference is, like why can't we accept one model with refraction compared to another model of refraction? In reality, we observe about a half a degree of refraction, and the globe Earth predicts that a flat Earth would require up to 25 degrees of special refraction.
That's horrible. The sun is half a degree. The sun is half a degree of size.
The other issue is the refraction causes it to appear higher than that. It doesn't appear lower. It appears higher.
The sun is half a degree in size, and he says we need 20 degrees of refraction. That's dishonesty.
He's bringing in his trigonometric, applying
floor.
trigonometry to the flat Earth, saying that the position of objects as they move away from us doesn't match what we
He's pretending he knows anything about the
trigonometry
model.
on a flat plane, therefore blah blah blah. That's all he's doing.
I want
It's a whole different argument than what we're having right now.
No.
I've been waiting.
Exactly the argument. You said, why can't we have one if it's on the other? And the difference is the amount of one that's going to be compared to the other.
That's a
That's
whole
the problem
different
that's
argument.
being-
So
No, that's
I
exactly what you
appreciate
asked
you
for.
answering the question. What my point is if we can have this appearance of the sun being somewhere it's not on one model, why wouldn't that be possible on another model? That in itself, regardless of your argument about trigonometry and everything else you're going to bring into it, I think you would agree that it'd be reasonable to assume we'd have a similar effect on both models.
Well, no, that's about as reasonable as saying because I can run a mile in 8 minutes, I can run a marathon in 8 minutes.
Yeah. You're using the same refraction on two different shapes. Doesn't work.
Well, is there two different types of atmosphere?
Is there two different refractions? Would the shape matter?
Well, you
The way the
yeah,
light would bend over a sphere or over a flat plane, would that matter?
Sorry,
Mr.
Bio.
Professional debater.
I don't think they understand.
Professional debater is all you
No,
are.
you don't
See you later.
understand.
Another one bites the dust. Go join Brenda.
May I ask you something, Bio? Now, can I ask about the 8 minutes thing?
Yeah, man.
All right. You said so when we're looking at the sunset, we're looking 8 minutes into the past of that sunset, that the light.
No, you're still seeing the sunset in real time, but the position of the sun.
But the
would be
sun is 8 minutes, right? So we're
If we
that
didn't-
light is 8 minutes in the past, right?
Oh, sure. Yeah, that's fine. If we
right.
had
Next
an Earth
question.
if we had an Earth with no
Sure.
atmosphere, then
Hold on, no, don't worry. My question is just about the minutes. So about the sunrise, are we looking 8 minutes into the future?
No.
What do you mean no?
What do you mean? We're still seeing the light that was transmitted 8 minutes in the past. We're seeing that.
What
light.
do you mean? Shouldn't we see the sun first then?
No, the fuck
We're
you
seeing
talking
the
about,
first
man?
glimpse.
We see the light.
We're seeing the first glimpse of the light, right? So
Right,
the
but-
sun cannot be in front of that light because we wouldn't
Okay.
see the sun. Yeah,
We're
right.
You've actually got a
we're seeing the
point,
light-
Bio. This effect cannot be caused by that delay in the sun because you're seeing the sun a few minutes before it actually rises. If it were delayed due to the 8 minutes, and that's what we were talking about, then we would see it 8 minutes after it actually rose, right?
Excuse me, Brandon, something
the
very
8 minutes-
important. Sorry, guys.
the 8
Excuse me,
minutes has
please.
nothing
It's
to
a
do
matter
with
of the
this
channel's
observation.
health. Please.
What's up?
George Nunchuck is shooting his mouth off about you know what, Brandon. Maybe you want to have a look at this idiot before he shuts down your channel.
Well, you just brought more attention to it, but thank you very much for bringing it to my attention. I'll take care of it. Thank you.
I got a question for the flat Earth community.
What
No,
is the
fuck
flat
your
Earth
question.
community?
Remember you said
Am I
Where's that at?
broadcasted?
Go
Why
ahead,
don't you
Barry.
have any evidence?
Can you hear?
You should have.
Can you hear me?
Yeah, we hear you. What's up?
So for the flat Earth community, what path does that sun take at night after sunset to return to the east to rise again in the morning?
Go to SunCalc. Go to SunCalc. All right. Hold on, y'all. Let me answer this. Go to SunCalc, okay, and look where the sun does like an elliptical half circle in your location, and then you can continue the sun. It's going to do the exact same thing, and you can continue the sun. You can project it for 24 hours. Go to SunCalc. So that thing is doing just a basic elliptical through perspective orbit. It works fine on a flat Earth. For y'all people to not acknowledge it, means you're not trying to acknowledge it. It's just an elliptical orbit. That's all it is.
And when you do that, the sun
doesn't work on a globe,
below the surface at night. The sun goes below the surface at night.
Bro, listen.
So
if the sun is
8,000
miles away, okay. If the sun is 8,000 miles away, okay, and it moves 2,000 miles to the right, how many degrees did it move? Do you know how to do the trig? It's not much, bud. Okay. If you know how to do the trig and you apply it to great distances, you'll see that perspective. No, I'm trying to teach you perspective, man. You seem like a smart man.
Related, Brian.
Brandon, I brought up a contradiction, a perfect contradiction in their model, and you guys don't see it. You guys don't keep on it.
Talking about?
It's amazing.
What are you talking about? I backed you up. We just talked about it.
I know you backed me up. I'm just saying, Brian, like they switched. We talked about this the other day, right? You point out the discrepancy. You point out a discrepancy in their model, and it's like you guys don't pay attention to what other people say. I'm trying to clarify.
I'm trying to clarify. I know. I'm going to explain it.
I'm waiting for your explanation. Yeah.
I know. So what you're talking about, this 8-minute delay, there's a delay in both directions. It's going to be the same direction. If we could remove the atmosphere completely, we have zero atmosphere, the sun setting would occur 8 minutes earlier. The sun rising would occur 8 minutes earlier. There's no fucking
man, who cares about that bullshit, man? Look, if
Brian,
Scott, hold on, tell us.
Are you trying to say that the light takes 8 minutes to go through just the Earth's atmosphere, not the 93 million miles?
Oh man, it's so difficult to break this basic shit down.
Basic horse shit, bro.
The time that it takes the sunlight to reach the Earth is 8 minutes. That's it.
But that's not true, right?
It's a good story, Kyle. It's not our model, but quit talking our model. That's not our model.
Brian, since you cannot remove the atmosphere, we cannot. It's just hearsay, right? This is something that you cannot show. So we have to hold on, Bio. So we gotta go with your model, which says that light, it's 8 minutes, right? We're looking at that light. It was there 8 minutes ago, right?
Yeah, I misspoke.
All right.
Let me restate it. So it does have nothing to do with the atmosphere. Me saying remove the atmosphere was a mistake on my part. What I meant to say is, if the speed of light was instantaneous, that's when we would experience sunsets 8 minutes earlier. We would experience sunrises 8 minutes earlier as well. It's just the speed that it's taking because of the distance.
Bro, you're talking about on a globe, you're only adding a few miles of the thickness of atmosphere, bro. They don't claim that atmosphere is making the big changes that you're making all of a sudden.
I misspoke.
Brian, listen, on a flat Earth, it would on a flat Earth, you're talking about thousands of miles, man. It would make a big difference, man. That's why I asked you earlier. What doesn't lower off in the distance? Name me one thing that doesn't get lower off in the distance. You can't. But you won't acknowledge that. You just argue without at least trying to see what we're saying. At least trying to acknowledge what we're saying.
Anything below your eye level, Brian, because that.
It's like Brian is not. It's like Brian is not listening to what we're arguing, right?
Nothing gets lower in the distance; it gets higher. And quite frankly,
if I'm not listening to what he's saying, I want to know so I know what I'm getting wrong here.
On a flat Earth, the horizon would be 1 1/4 degrees above your eye level. On a flat Earth, it would be above your eye level.
Why would it be 1 1/4 degrees above your eye level?
What's the size of the sun, pal? they say the angular size of the sun is half a degree, you know, and then they say we need 20 degrees for it to set. It's just horse shit, man. They got their own straw man flat Earth models, man.
Oh, why is that?
It's
geometry
the math. Hang on, it's the math. If the horizon
a cloud 11 miles away is just right above the tree line.
You do the math and show we're wrong.
I've done the math, you fucking lying sack of shit. I've done the math. I've showed the math. Okay, I will put it up right now. God damn, you're dishonest, man. The sun in your model is half a degree, right? Half a degree. That's angular size, right? So all we need is half a degree of refraction. You got 15 degrees of refraction in your model.
No, it's half a degree of refraction.
Yeah, but in your model, as well as our model, the 15 degrees from the ground up is unreliable.
That's not our model. You don't know our model. All right?
I think I do, buddy. In your model, 15 degrees to the ground is unreliable. Is it not?
We know ours. You present your model.
Okay, well then let me clarify yours. From the ground up to 15 degrees, is the information reliable?
What does that have to do with what's being argued?
Yeah, and your model does. And your model, from the ground up to 15 degrees, is fucking unreliable. Okay? What's different about our model?
I'm not going to address our model. You have to tell us about your model.
Okay, and our model, from the ground to 15 degrees, is unreliable. How about that? Same as your model, jackass.
Not our model. I'm sorry. Not our model. It's Brian's model. I don't have a model.
Brian's model.
Thank you.
Okay.
Model.
I've got a point to make here. So I'm sharing my screen. This idea that you would see the sunrise or sunset lower or after or before it actually rose or set on the heliocentric model is total bunk. And here's why. That would only be the case if it were the sun that was moving around, because the light as it moves would take 8 minutes to reach the new position on the Earth. Since it's the Earth that's spinning around, the sun is always shining in your model on half the Earth, and the Earth spins around. All you need to do is be in position to where the sun is shining from the sun, and you should instantly see the sun where it's at, right?
Right. The claim comes in whether the speed that it takes is a speed or if it's instantaneous. That's the meat of the argument.
Yeah, that's what I'm saying. In a sunrise, you're seeing 8 minutes into the future in your model, which is fucking retarded.
The future.
You might be hold on a minute. You might be seeing light that is 8 minutes old, but as soon as you're on the Earth and you cross that terminator line, where you are facing, hold on, where you are facing the sun. Hold on. As long as you are on the Earth and you move into that point past the terminator line where you're facing the sun, you will be in the light. However, if it were the sun that was moving, if the sun was moving around and it came over here and passed the terminator line where you are, it would be 8 minutes before that light would reach you, right?
Essentially, if you had the power to turn off and on the sun, sure. But whether the Earth is rotating or the sun is revolving, the same effect on Earth would occur.
I don't think so.
How do you see the sun rise 8 minutes before it happened? We're supposed to see the light 8 minutes later. So seeing sunset 8 minutes later is fine. But how are they then saying they see the sun rise 8 minutes before it's risen, 8 minutes before the light? We should be seeing it 8 minutes later.
Because the argument.
Perfect. No, hold on, Bio. No, not only that. But at what point you're seeing into the future to the past, and there's got to be a point where. This is not a straw man. It's just it's understanding the consequences of your model. It's understanding the consequences. Hold on, Brian.
Fucking spiraling, man.
For anybody who cares, I posted my math and my revised refraction model. Brian's refraction model on a flat Earth.
Brian, bro.
In general, go ahead.
It's just an argument between the speed and the delay.
Finish what you're saying, dude. Hold on, let him finish, dude. I just wanted to say I posted in fucking general my fucking math that they asked for. Okay, it's in general. Go ahead, let him finish. Let him finish. Let him fucking finish, dude.
All right, Bio. When the sun is going away from you, that light you're looking at it already passed, right? It already passed, and you're looking at that trail of that light coming to you from 8 minutes ago. Okay.
Basically.
Now, when the sun rises, you cannot have the thing from the that is emitting the light in front of the effect that you're gonna see. You're gonna see it out front.
That's exactly what's happening, because we're not gonna see it up front, because the light in it. All that's being discussed is instantaneous position of the sun and the earth with you on the surface, and then the delay that it takes. So what you're talking about is consistent. If light traveled suddenly instantaneous for a sunrise,
no, don't bring instantaneous. I don't care about that. I'm talking about your fucking 8 minutes. I'm talking about your 8 minutes.
Yeah, you're talking about the time that it takes. If it were instant, we would have a different effect than if there was a delay. Yeah, of course.
Bio, on the other side, the light was 8 minutes
You
there
have a
before.
model already.
Because the earth is the one moving, not the sun.
Right. So the position of the sun has already been there. So when it's on sunrise, the
light was there before the earth got to that point.
So fucking, you're so crazy that you think a thing, but you won't let me fucking respond to that thing, man.
Because you don't understand what you're saying, bro. You're fucking stupid. How can you have the sun, which is emitting the light, not visible on the fucking sky, and then you're gonna see the light 8 minutes on the fucking horizon? Are you retarded?
Because you're confusing instantaneous position of things with the delay of the light coming off of those things. That is your confusion. Well, with the explanation and all the pedantic technicalities, the sun is in a different position than at sunset when we see it. In physical reality, it is existing in a different position from when we see it by about 8 minute delay. The same occurs on a sunrise. When we see the sun, that's the apparent position. The physical location of the sun already rose 8 minutes ago. It's consistent.
Holy shit, listen to this guy. Listen to this shit. This is why we cannot get on board with this shit. Bio, that's fucking retarded. If you don't see the fallacy, the failure in your logic, it's fucking stupid, bro.
You know, you can scream all you want, bro, but he's exactly right. So why don't you shut up?
You could only ever have those 8 minutes following you, not being in front. You can't have those 8 minutes in front of the sun that's giving the light that causes the 8 minutes. I mean, really, guys?
Did you guys hear what I said? I mean, it's like, was I completely wrong, or did you guys just not understand? There would be no 8 minute delay in the heliocentric model. The Earth is moving you into the light. There would be an 8 minute delay if the sun were going around the Earth.
That's a key word. That's a key word. Moving you into the light and moving away from the light. It's like the fucking sun that you guys love to bring.
Brandon.
There's stays in the light.
Brandon, it has nothing to do with whether it's moving into or out of. It has to do with the distance between the sun and the earth. So unless the sun...
And when you're moving away, hold on.
So unless the sun is 93 million miles away on the flat earth, you don't have an argument here.
He said about the distance. I'll give you the argument. So when you're moving away, are you creating more distance, yes or no? And when you're moving to the object, are you shortening the distance, yes or no? Fuck you. See? You guys have no logic.
Yeah, he won't answer that. You're right.
No,
that's the implications of that.
It's not Dan. All right.
The donkeys.
Yeah, it's a stupid question, so I don't feel the need to answer it. I mean, what are you talking about a change in distance here between the Earth and the Sun?
How you just said like 30 seconds ago you said that. You said it was an argument about distance, moron. Are you this lucky, man?
All right, hey, listen, guys. Hey, listen, guys. I don't know why everybody's so upset. I don't know why we're being like this, but
Brandon,
let's all take a
question.
fucking
I try
breath.
and answer it.
I understand. I understand. I'm not pointing to any one person. I'm saying let's just calm down, give each other the chance to speak and respond and have a discussion.
Yeah, a model of reality. The sun gets further away, it gets dimmer. It gets dimmer. So when it's furthest away, we can look right at it. Oh, where does that happen? Reality. So he asked you a question about distance. Answer it, donkey. Sorry.
Sorry,
Brandon.
The only distance that changes has to do with the orbit. It's about 4 million miles over the course of a year. We're closest to the sun in December and furthest away in June. The difference between the two is about 4% of the total distance. That's it.
Yeah, change the subject. Change the subject. Yeah. Change the subject.
You asked me what distance it was. It's about 4% change, not much. And it's over the course of...
You never answered my question, though.
You haven't formed a question yet. Try again.
All right. Let me ask you nice and easily, because English is my second language. When you are moving away from the sun on the rotation of the earth, are you creating more distance? Yes or no?
Not in the scale between the earth and the sun, no. Essentially, nothing.
I give up.
As you should. It's about...
It's insignificant.
4,000 miles compared to 94 million. It's 4,000 miles compared to 94 million. That's insignificant.
Yeah, but those 4,000 miles create...
It depends on the time of the year. Because half the year we're moving away from the sun, so
we have the time of the year.
It's nothing.
So if a couple of thousand miles really changes the temperature here, so what about 4 million miles? Nearly 4 million miles.
It's not the distance that changes the temperature. It's the angle of the rays coming in.
Is how much power per area you get from the sun.
You do understand the concept of axial tilt, right?
Let me ask you a question, Bob.
Go for it.
Okay, now, the sun is brightest when it's right overhead, right?
I guess you could say that. Yeah, why not?
Okay. And my refraction model, my flat Earth refraction model, okay, I got from 63 degrees up to 90 degrees, there's no refraction, okay? And it works its way down to 100 degrees at 1 degree from the horizon to 1 degree. It's 99% of 6 inches per mile squared refraction at 2 degrees and 98 at 3 degrees. Okay, it's like but anyway, but in my model, as the sun gets further away, it gets dimmer because it's cutting through more atmosphere. So when it's on the horizon, it's cutting through the most atmosphere. We can look at it without even shades. How do you explain being able to look at it in your model?
Same thing.
Yeah, basically the amount of atmosphere you're looking through.
Okay, so a few more miles, so just a few more miles of atmosphere with a sun that big and bright and that powerful is going to make that big of a difference in just a few degrees. I mean, that's a tough one to swallow, man. I'm just telling you. But in this model, I posted it in general. Go ahead. Well, listen, in this model,
it or not, it's the way it is.
I posted it in general. It's my revised refraction model for flat Earth model, and they're right. I got to claim it. It's not a flat, but it is my flat Earth refraction model. And if you use it, if you take the angle to Polaris, if you take the angle to Polaris and you apply this math, the refraction math, depending on what degree it is above the horizon, then you get your latitude, or you'll get your distance to the North Pole. Okay, and that's based on from the equator to the North Pole being 6,200 miles. That's based on the sun being 3,620 miles, based on Polaris being 3,655 miles, and based on the moon being 3,550 miles. It's all on the model, and the table for the percentages is off to the right. I posted it in general.
Nice. I saw that.
Through it all, man. I had a hard time presenting this before, but
I looked at your map. I looked at your math. Where'd you get those numbers from? Did you just make them up?
No. Where'd you get 7/6R, Bob?
We measured it. Now, where did you get the distance?
I measured it. Exactly. Good answer. I measured it.
All right. Where's your measurements?
In reality, bud. In reality.
You measured that.
These are measurements we can prove in reality. What are you talking about?
Brian,
just
flip the question to him.
Show me your method and let me measure it.
Flip the question to him about the horizon.
I think it might be a reification. I don't know.
Right, go ahead and show me where those numbers came from.
The horizon is where the floor and the ceiling appear to meet.
I'm talking to Brian. Lemon, I'm talking to Brian.
So Brian, if the sun is hot,
tell me where those numbers came from.
Okay, look, I applied them to reality. Let me say that again.
How did you measure?
Using AE map. What are you talking about? I used reality, and I applied the math. Okay, where did you get 7/6R from, Bob? Tell me how you measured 7/6R, Bob.
We measured it directly. You can measure it by length. You can also
show me what you mean. So you use reality, right? You use observations in reality, correct? I did the same. I used observations in reality.
Look at Brandon and I talking about the black swan. We measured it right there in that video. You can look at the video and see.
The black swan kills your geometry, pal. You don't want to admit it. I know you're in denial, but you got no more geometry.
The black swan doesn't kill shit.
What the black swan shows? What does the black swan show to you, Brian?
It has you say that it's refraction. In other words, the horizon is refracted. So we're not doing geometry to a refracted horizon.
Right,
whether you want to admit, that's the only way to get an accurate
rambling, Brian. Calm down.
I think I'm pretty calm, bud. This is pretty fun. This is a funny part of the show here.
You're the one screaming, Bob. Come on.
You. What does the black swan show to you? What does that tell you about the shape of the Earth?
The black swan shows me that the horizon is refracted, so no more geometry. Deal with it.
How is the horizon being refracted have anything to do with the shape of the Earth?
Don't talk me. Just deal with it.
I'm sorry, but the best that you can claim out of the black swan is that the Earth is a sphere with a radius of 9,000 miles. That's the best that you can claim.
Here's the honest thing I can claim is that the horizon is refracted.
I'll take that one. Therefore, your moon landing is fake. Your orbits are fucking fake. Every single calculation on orbits are fucking fake.
The size of Venus, all of it.
So, just out of curiosity, has any of you guys ever actually seen a black swan, like an actual black swan?
All the time. I got them in my camera right now. Oh, no. Actual bird?
Yeah.
No, I haven't. Not in real life. And I've seen a couple pictures of them.
So the reason that they call it that, right, is because the existence of a black swan means that not all swans are white, right?
No.
Right? No, is that wrong?
No, it doesn't claim. Guys.
It proves the statement that all swans are white.
Exactly. It's because the claim is that all swans are white. It's
right.
different than what you were saying.
The things that you're forgetting is that the existence of a black swan still means that lots of white swans still exist. And as you guys just said, none of you have actually seen a black swan in real life.
Sure,
so
but it proves the statement all swans are white as wrong. So all horizons are Earth curve is wrong.
But it also does not prove the statement that all swans are black.
That's not the claim. The claim is all swans are white. We can show one black swan and say, no, not all swans are white.
Yeah, y'all are saying the black swan. Y'all are saying the black swan eliminates the possibility of a globe, is what y'all are saying. You're saying, in essence, that there are no white swans.
Isn't the claim that the Earth is...
All that does is raise a question about whether the radius of the spherical Earth is larger than it's reported. That's all it does.
Yeah, but you've already used the so-called radius to go into space and to measure the
There's no such thing as a so-called radius. There's no such so-called radius. There's the radius of the Earth. There's the actual
Well, Bob, if
radius of the Earth,
it's
and there's
bigger,
the
then it is a
radius.
so-called radius. Because if it's bigger, then the radius you're using to do all the math to get your stuff into space is all wrong. So, even if it is a bigger ball, you guys are screwed.
The refracted radius is the refracted radius is
the show over, Brandon?
No, we're still live.
Brandon there? Oh,
we're still live.
Oh shit.
The show never ends, man. It never ends, man. It's all yours. Go ahead.
Maybe not.
Go on. That's my singing. You like it?
Once it's over.
I want to show you guys something in a minute here.
Yeah.
Because I don't think I'm right, or that if I am right, that you guys understood me. So I just want to clear this up. Can you guys see my screen?
Yeah.
All right. So here's two situations. The top situation is this white is just the surface of the Earth, okay? You can think of it as really any surface. And this is the sun, and this yellow is its beam of light. This is the area that hits is the base of the triangle. It goes from this sun on top travels from each red arrow to the next takes 8 minutes. Okay? 8 minutes, 8 minutes, 8 minutes. So it starts off here, and then it goes here, 8 minutes. The sunlight takes 8 minutes to travel. So when the sun is positionally over this arrow, the light won't hit it until it gets to this arrow, correct? If it takes 8 minutes to go from the sun to the surface. Okay. On this one, the Earth moves. All right. I think I did it backwards, but that's okay. The Earth moves. So the sun is stationary, and the Earth moves underneath it. So it's always pointing its light down in this vicinity. If you look up from this spot on the Earth, you're always going to see a sun. And the Earth moves 8 minutes for the distance between those red arrows. 8 minutes. There is no delay between the position of the sun and your position on the Earth if it's the Earth moving. Here there's a delay because it's moving from position to position, and it's taking until the sun is at the next position for the light to hit you. Here, the light is always shining, and you're just moving into the area where it's shining. So there's no delay.
That's still incorrect, Brandon.
The position where you see the sun and the actual light hitting you, there is no difference positionally or apparently.
Brandon, you're going to explode your brains, bro. Don't understand 3 dimensions, bro. You're going to explode your brains, bro.
You're still incorrect, Brandon.
And therefore, that's why I was saying, Brandon, when you're moving away, because that light is not changing positions. It's there all the time. So we're the ones moving. So when we're moving away, we're looking into the past. When we move into the light, we're looking into the future of that light.
Okay. We're getting light from the sun. That is, so when we move in, when this moves into the light, hold on, when this moves into the light, yes, you're right. The light that's coming from the sun is 8 minutes old, but the position of the sun and the apparent position, it is not affected by that delay because that is always where the light is shining. You're just moving into it.
Oh, you're right, Brandon.
Here, the sun's moving, so the light doesn't hit you until it gets to the next arrow. So it starts off here. There's no light there, right? When the sun is overhead, the light doesn't hit this position number 1 until the sun is here. Same for when it moves from here to here. Now the light hits here. So the apparent position is different than the actual position because of the delay. When you are moving, there is no difference. Do you guys get it?
Actually, there is.
Yeah,
we tried to tell you that, but you're not listening.
What am I wrong about?
I think we just find a new flaw.
What am I wrong about, Bob? You have to tell me. You can't just say you're wrong.
On your lower one,
you sound like an Aries failure experiment, Brandon. That's what Aries failure proved.
Well, you took a long time to respond. So what am I wrong about?
All right. The only thing that matters is the distance from the sun to the earth. That distance requires 8 minutes to travel. Whether the sun is moving over the earth or the earth is moving under the sun, it still takes 8 minutes to travel. And you're still going to get a delay from where the sun is actually located versus where it hits the earth.
No, Bob, I just explained that. I just walked through it. So here, the sun is moving. You're not seeing it where it's in a position. Here, the earth moves.
Brandon,
You're just moving into where the sun is
I don't
always
think
shining.
the
So are you
screen.
telling me these two are exactly the same? Why would that be? The position of the sun doesn't change in this one. Just your position. You don't get hit with the light until you're under the light where the light is shining, right? And when you're under that light, the sun is where it appears to be because it doesn't move.
No.
Bob, you think about this one because I think that
I
this
already
is
have.
pretty
I
damn
already
simple.
have. You're incorrect.
Well, you're not making a very good case for why
So,
I'm
Brandon,
incorrect.
I don't care if
Yes,
you
the
think
delay
it's
is always
Brandon,
8 minutes. The delay is always 8 minutes, but it's the positionality.
Show your
The
math,
difference
Brandon.
between
Show your math.
its apparent
Show the math.
position. There's no
Show the
math
math,
to do
Brandon.
here, Bob. There's no math.
We're your peer buddies.
Yeah, there is.
There is
There's
no
always
math required
Show
here,
the math.
Bob. I just did everything that you need to know in order to understand
Show
it.
the math.
It was done
Show the
1,000
math.
This is very
years ago, Bob.
simple.
What math do you need? It's been
Someone
done
else
for
was trying
thousands
to
of years.
argue.
Brandon, can I ask you to do something?
Well, if you can demonstrate it with, if
Brandon.
it's simple, you can
Yeah.
demonstrate it with math. Go right ahead.
Bob, that's
What
a
are we
cop out, Bob, and you know it.
And you don't need math.
No,
You
What are
just
we
need to
doing?
understand
Are
how
you
the
playing me and
movement
my
works.
son with math?
So if the sun is
How do you do
moving,
that?
it's changing the position where it's essentially broadcasting the light to. Okay?
How are you backing your math?
Whereas if the earth is moving and the sun isn't, then there's no change to where the light is being broadcast to. It was there to begin with and continues to be there because it's not moving. The earth is. So if the earth moves underneath the light, the light's already there. It didn't need to travel anymore because it's already there.
I think
Exactly.
they think the sun
Bob,
turns
you
off
get
at
it.
night.
And Bob's math is wrong anyway. It always has been.
There's no math required for this. Who was that speaking?
Brandon.
Dogma? Yeah.
I know that. I'm just saying.
Yeah. In both cases, in both cases, it would be the same. In the upper one, the sun is moving towards you. In the lower one, you are moving towards the sun. But the effect is exactly the same.
You're going to have to go a little deeper than that. Why would the effect be exactly the same? Here, the position is moving. That's why the apparent position of the
Okay,
sun,
well,
position in,
move
in
it
the light
in the
are
upper one,
different.
okay?
Okay.
Move your upper sun. Okay, let's say you're the arrow on the far right. The sun is moving towards, okay, move the sun to the right. The sun is moving, and now it's over the arrow on the right. So in that case, you move the sun towards the arrow. Now do it on the bottom and pretend that you have an arrow on the right on that bottom slab and move that to the left.
Here, I'll just do it on the same one. So here the Earth's moving, right?
Well, on your bottom one.
I mean, if you're
okay,
saying
now
that,
on the bottom one, you're
This is I had them backwards the whole time. This is
now
one
on the
with
bottom one. Yeah, so if you had an arrow on the right, that sun would be moving towards that arrow. In both cases, the sun and the arrow are getting closer.
Yeah, that doesn't. No, that you're missing.
So I don't
the
really
point.
see what the
think about it,
difference would
actually,
be.
Happy Dogma,
think about it
I
this
want you
way.
to think about this. I want you to think about it a little
may I
bit,
say-
both you and Bob.
May I say something, Brandon?
Because I can tell from your
okay.
responses that you're not understanding the argument at all. Just being straight up.
Wouldn't it actually depend if you think it's a constant stream or not? Because if you think about like water, like a stream of water, whether you move where the stream is coming from over the plane or over the whatever you're shooting it at, or you move the thing underneath the stream of the water, if the stream has already reached that part, it would be the same. So the question I think it actually comes down to, is the stream constant or not from the sun? Is the stream of light constant or not. If it's constant, then it won't be different. It's going to be the same.
A stream of water is not a good analogy because it's almost instantaneous from like a hose, right? The thing that is causing this, the apparent position and its actual position to be different when the sun moves, is because there's an 8-minute delay. So when it's here, you know, there's no light until the sun physically is over this spot because of the delay in the time that the light gets there. So it's always the actual sun is always 8 minutes physically ahead of the sun by the time the light is there. It's always 8 minutes ahead of the light.
But like as it's moving, it has already sent out the light. So what I'm saying is, like at the very, very beginning, if you think this is true, which I don't think that light has a travel time, but if you think that this is true, then like the very, very beginning of light from the sun, you would have had an 8-minute delay. And since then, it's been constant, so you would never detect a delay because it's been constant the entire time.
No, because it's always moving. You wouldn't see it.
You'd really have no
You wouldn't
idea
be
that
able
the
to-
sun, that light traveled for 8 minutes. You would just see it.
Right.
You would just
You wouldn't
see
have
it.
any
So
idea.
The difference is its actual position and its apparent position. So
If we
when
could tell
you
the
see
difference
the
between
light,
actual
when
and
you
apparent,
see
then that
the
might...
light here, yeah, there's no way to observe this. You're right, because
Right.
you have to know.
Okay, then yeah, maybe not. Maybe I'm just if you agree that there's no way to observe it, then you get it.
Yeah, there's no way to observe it. You have to know the actual position of the sun somehow,
Okay.
and know where the light
Maybe
is
not.
in order to actually observe
Maybe
it.
not.
This is theoretical. In this one, the light is always 8 minutes behind. The apparent position and the actual position are never the same, right? Because it's
Well, the
constantly
8-minute travel
moving.
time was
Constantly moving.
Yeah, but again,
the
all
8-minute
you
travel
would see
time.
is the light that reaches your eyes.
No, this one you're just moving into a stream. So when you are in the stream of light, the apparent position and the light are the same. This 8 minutes is a constant flow. The sun's not moving. You're moving. You're just moving into its stream.
Well, on the
Well,
globe,
yeah, but
on the
in
globe,
the
they
upper
say,
one,
hold on a
the
second, please.
stream
Can I
of
just
light
get in real
is
quick?
moving towards you.
Jesus Christ, this fucking guy. Can on the globe model, if you see it 8 minutes sooner, you should lose it 8 minutes earlier, not see it 8 minutes longer.
Well, this was theorized from the time it took one of the moons on Jupiter to eclipse. It was 8 minutes sooner or faster based off of where it was in the orbit. King's Throne goes over how this is highly theoretical. This idea that light travels 8 minutes to get to us or whatever. It goes over how they theorize this based off of the eclipse time of a moon on Jupiter. I don't know if that's a sound theory.
Not true.
Yeah.
That's not true, Lemon. That was how
They
it was
can't even
first-
prove 8 minutes. We know. The point is that
No.
you shouldn't
Hey,
see it.
I'm
You shouldn't see it
fucking-
earlier. You shouldn't see it earlier for a sunrise, and then see it later. You should lose it earlier.
There should
If
be
that's
no
the case.
delay on Earth in the heliocentric model.
I was talking.
There
The-
should be
the
no
eclipse
8-minute
of Io
delay.
is
There
the
should be
earliest
no
way.
difference
Oh,
between
fuck
the
it. Go ahead.
apparent and
Talk
the
over it.
actual position on the heliocentric model because it's the Earth that's moving, not the sun.
Bob, you were saying? Dr. Bob?
No, I'm not going to
Thank you,
answer.
Dr. Bob.
I'm trying to avoid talking over people.
Well,
Go
it
ahead,
was
Bob.
the show host who was talking, Bob. So stop being so butthurt and just say what you want to.
What's so profound about this idea that it's not in the position that it's supposed to be in?
Well, it's not that profound.
It means
It's the fact that somebody made an argument earlier that there was an 8-minute delay, which caused a difference between the apparent and actual position of the sun.
Right. Isn't that true for everything?
I think that would actually be due to refraction, not the 8-minute delay.
The medium.
Bio said it wasn't refraction.
The
Be
medium.
careful there. Be careful.
Listen, I'm not being careful with shit.
Doesn't have anything to
Not
do
you,
with
not you, D-Mark, not you.
Oh.
Bio said that it wasn't atmosphere. So I'm just saying to their own side to be careful with the argument because you're about to contradict the argument of the other guy.
Well, I think that's two different arguments.
It is atmosphere. It's the atmosphere light has to travel through, just like a gallon of water,
The speed of light is known. The initial measurement of the speed of light was by eclipsing the moon Io on Jupiter, but it's been refined since then. The speed of light is well known, and the distances are also well known. So the delay between the light being emitted and the light being received on the Earth is 8 minutes based on the distance and the speed of light. It's not subject to debate.
You don't have a speed of light.
Of atmosphere. When you see light and you look down a road that's hot,
we have the speed of light. Yes, it's been measured.
What's that atmosphere do off the hot road? It bends everything. Yeah, if you guys knew
agreed upon convention.
You quit making a complete ass.
I'm not. Can I give you a better way to exemplify this?
Yes. Shine light.
Yeah, I'm not going to argue with it. It's an actual measurement. So you can call it what you want. It's still a measurement, and that's the way we're going to treat it.
And nitrogen and helium.
So if we were to shoot a bullet to the sun, when we see it straight above us, would we hit?
Don't have 93 million
making noise.
You do not have 93 million miles worth.
You're making noise.
You have no experiment. You are full of shit. You have no math.
Let's at least hear from Sharky. That way, because there's always a conversations going on here.
Well, we're talking about light, and he's about to bring the fucking. He's about to bring the sound that you guys so much love and try to compare
No, this
to
is related though. That's a good. I thought Chucky's question was a fair question. I thought it was a fair question.
So
the question was, when we see the sun, we shoot at it. Would we hit it?
Would we hit it?
Theoretically, if we could shoot 93
whether the
million
sun
miles,
is moving or us.
If it is not moving, if the sun's not moving, when we see it and we shoot at it, we should hit it. If the sun is moving and we shoot at it, when we see it, we should not hit it.
You forget conservation of momentum.
Oh my God! For fuck's sake,
you haven't proven that.
You see?
I should have never went along with this.
So you wouldn't hit it, right? Either way, you wouldn't hit it.
On your model,
right, Chikey. In reality, either way, you wouldn't hit it. I mistook it for a reasonable question. But
yeah, and the same would be if you shine a light on it. You wouldn't hit it.
There you go. The how you say that when they verify something with other things.
Shining light on the moon.
Anyway.
See, they compare something that and then they insert the other thing as if it was the same.
Yeah, they actually do shine light on the moon.
And you can measure a refrigerator. They say you can measure a refrigerator. What would you be able to measure the stars? It's like at that fucking point, it's not worth it to argue with these people anymore.
Silent, weren't you there when I asked my angular size question and no one except one knew how to answer?
I give you the answers. You're just too fucking dumb to understand them.
I got you one, Chai.
The answer?
Right question.
The answer was the number.
Or your cognitive dissonance doesn't let you. All right, Dima, go ahead.
He's supposed to look out a window.
Cognitive dissonance, drink.
He's supposed to look out a window and have a flat earther or a glober in the distance or two, and they're supposed to pop up an object he's never seen before, and he's supposed to do the calculation. He gets one try. He can have Google. He can have whatever he needs, right? He has to sit right in a chair, look out the window at the object. He has to give the size of the object, the height, the density, the weight,
right,
distance, and the distance with his calculations. Because, yeah, and you can use spectroscopy. You can use whatever you want. We even want to know what's in the barrel, Chai. Since you guys can look at a star and look at a planet and know what it's made of, the density, the size, the core, everything else. So you need to do all this shit on Earth and have the actual object right there so we can say, huh, Tyke was full of shit or he wasn't. Check that out, boys. Bob, you can do it too. You want to help him out, Bobby boy? Because we're going to need somebody that thinks they're good at math. Because all you get to do is look. You can't go touch the object. You've never seen it before. They pop it up one time. You get one try. Do your calculation. And then they say, all right, I got my calculation. You say, all right, you give it, then we compare. And when you're off by the size, the density, the height, the distance, and then we'll talk.
Can you know how far you are away from the object?
Well, I think that's about as good any point to stop for the night. Hope you guys enjoyed the show tonight. Thank you very much for being in the chat and being so active. I appreciate it. Thanks for watching. And shout out to Godzilla, Silent Zero, and there's one more. I even said Will. Thank you very much for the super chats. I appreciate those. We'll see you guys tomorrow, and have a good night.